Hello and welcome to this course on creating the user interface in Android Studio. These days, smartphones are everywhere, and you probably know that most smartphones run on Android or iOS operating systems. But did you know that smartphones running on Android holds around 70% of the market? That means that most people use Android smartphones and therefore they use apps built for the Android operating system. But do you know what a mobile application really is? How does it function? How important is application development? To put this simply, a mobile application can be simply defined as installable software that utilizes your device hardware to function. The number of mobile applications has grown tremendously over the years. You can find apps for a multitude of services. For example, with a fitness app, you can set goals, track your activities, and share them with your friends. Social media apps allow you to post updates, share photos, follow friends, and much more. Restaurant apps can let you order dishes, customize them, make reservations, among other tasks. These examples and other mobile apps are designed and developed to work on your device. Mobile applications can be built to perform a variety of functions. Hence, Android developers should be able to code in programming languages like Kotlin or Java. Use application components like activities and services. Use an Android app development tool such as Android Studio, and build native Android UI with Jetpack Compose. But don't worry if you don't fully understand these terms now. This is only a quick overview of the Android application development. You'll learn more about these concepts throughout the course, as well as complete other assignments that will aid you in creating beautiful and functional user interfaces in Android. You'll start learning how to create a basic UI in Android, as you are introduced to different approaches to building UI with Kotlin using Android Studio. You'll explore how mobile UI is built and the unique challenges for Android UI. You will get an overview of how to build a simple UI using traditional view system and the layout editor. And then you'll start learning how to create a simple UI using composable functions in Jetpack Compose. You'll discover Jetpack Compose in more depth and understand how composables are decorated with modifiers, how it handles state management, and how to better lay out composables based on material design guidelines. This will prepare you to build a responsive UI with different layouts. Next, you will continue learning more and cover advanced UI with Jetpack Compose. You'll start learning how to build interfaces that consist of multiple screens and extend beyond visible screen area and implement navigation between these screens. Finally, you will learn about UI styling. You will practice applying themes, custom styles, and animations by applying transitions and constraints to develop attractive UI. But don't worry, you are not expected to be an Android mobile developer just yet. There are many videos in your course that will gradually guide you towards that goal. Watch, pause, rewind, and rewatch the videos until you are confident in your skills. Then, consolidate your knowledge by consulting the course readings and put your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. And you're not alone in considering a career as an Android developer, which is why you'll also work with course discussion prompts that enable you to connect with your classmates. It's a great way to share knowledge, discuss difficulties, and make new friends. To be successful in this course, it is helpful to commit to a regular approach to learning. You need to keep committed to your learning, and if possible, create a schedule with dates and times that you can devote to your study. It's an online self-paced course that allows you to study when and where you choose. But regular study patterns do help many students to learn better. In summary, this course provides you with a complete introduction to Android mobile application development and forms part of a program of courses that will lead you towards a career in mobile application development. Adrian and Mario have decided that they want to develop an app for the Little Lemon restaurant. They realized that in addition to improving revenue, a mobile app will be a great facilitator in getting to know their guests and be able to serve them better. They have asked you to develop a UI or user interface. In this video, you will learn more about what a mobile UI is, explore what is important when designing and building a mobile UI, and discover the constraints and some design issues when building a UI in a mobile application. A mobile UI is the display or screen on a mobile device. It's where users interact with what's on the screen, such as menu buttons and text fields. Most of these user interactions are touch-based, and the fundamental principles of mobile UI design differ from those of traditional desktop UI. After all, users are on the move by definition. Control in the UI is limited due to the screen size, so big, bold, clear, and simple actions and information are required. Users nowadays have a lot of choice and freedom in finding mobile applications that work for them. However, a poor user experience can quickly devalue a brand, hurt revenue, and disengage users. Today, you can't build an app and meet the user's expectations without having a polished user interface. Before starting the development process, let's look at some design considerations and principles. Designing mobile layouts isn't all that different from creating any other type of layout, but there are some things you should keep in mind. Putting users in charge of the interface will make them feel at ease. So, they will learn quickly and get a sense of achievement. And the user should always be able to reverse their actions quickly. This allows users to explore the product without fear of failure. Knowing that errors can be easily undone, it encourages users to explore unfamiliar options. A streamlined and user-friendly UI will result in focusing on users' goals, minimizing navigation options, and generally removing anything that isn't necessary for users to do. Aim to design a UI so that all information presented on the screen is useful and beneficial. Examine each element and rate it based on the value it provides to users. Ensure that the user interface is consistent, including similar design patterns, the same wording and prompts, menus and screens, and consistent commands across the interface. Another area to think about is hand position controls and the thumb zone on mobile devices. This is the portion of a phone screen that can be easily accessible with the thumb when a person is holding their phone with one hand. To create a favorable user experience, it is crucial to place the majority of interactive content and especially calls to action in this zone. Another important consideration while designing UI for mobile applications is to make them flexible and adaptive. This means reorganizing the layout of the various UI elements based on the window size available to the app. The emergence of foldable mobile devices has highlighted this need even more. In a mobile UI design, a clear typographic hierarchy is critical. Titles and headers should be visible and fonts should be more prominent in general. Clear headers, bulleted or numbered lists, and short paragraphs all help to improve the legibility of mobile text. Another way to boost user confidence is to provide feedback as they navigate and interact with the interface. A loading animation that informs the user that their request to visit the page was successful and that the content is being retrieved could be the first point of feedback. An animation can be an important signal to a user that the action they just performed had an effect. In a mobile app, animations and precise transitions between screens or functions are essential pieces of feedback that contribute to a more satisfying user experience. Users are more impatient than ever before. They have a low tolerance for slow-loading apps because almost everything online happens instantly and in real time. In general, you should aim for a page load time of 3 seconds or less. Any longer, and your users may begin to leave. With an increasing number of people connecting via mobile devices and an increasing number of apps being developed each year, getting your mobile app UI design right the first time is critical to attracting and retaining users. An excellent user interface should be easy to use, easy to navigate, and so intuitive and natural that it is almost barely noticeable to the naked eye. Now that you have some UI design considerations and constraints covered, you can move on to developing the Little Lemon app using Android Studio. Android Studio, which is the official development environment for Google's Android operating system, has addressed the issue that you can't build an app and meet the user's needs unless you have a polished user interface that includes animation and motion. To resolve the technical challenges of quickly and efficiently creating a polished UI, they introduced Jetpack Compose. This is a modern UI toolkit that enables app developers to succeed in this changing area. You will learn more about this feature later in the course. You should now be more familiar with what the constraint and design issues are when designing and building a mobile user interface. Great job.
Did you know that there is more than 24,000 different device models operating on Android? Such a variety means that anybody can find what fits them the most, but it also means that there is a huge variety of devices that you need to support when building an Android user interface. Hi, my name is Stepan Fordey. I'm a full-stack engineer at Meta working on Ads Manager. My first Android project was a banking client app. Working on that app, our team focused a lot on both security and usability of the app. We built our first user interface layout fairly fast, but when we started to test it on the phones with smaller screen sizes, we noticed that account balances and transaction amounts didn't fit on the screen. So what use can be a banking app if you don't see any numbers? We quickly learned how to prioritize the information on the screen, how to structure the layout so that the most important information is always there, what can be moved, what can be deprioritized. So screen size is just one of the factors that makes building the Android UI challenging. You always need to think about how will your app look like if your user holds the phone vertically or horizontally. They can also use different languages, not the one that you speak. And different languages have different length of words. And it's very challenging to find a layout that would fit all of this diversity of needs. At Meta, we create libraries and frameworks that help us build scalable features, hundreds of them, without learning same mistakes and implementing same things over and over again. Our UIs can read left to right and right to left and scale for a lot of different font sizes, fonts, and languages. We always keep track of which phone models are most popular among our users, and we make sure to test and verify how the products we build look on those models and across many different languages. Though sometimes hard, building Android user interface is one of the core jobs of most Android engineers. User interface is the face of your app, and it's also what makes it usable and efficient on a daily basis. So it definitely pays to invest in learning how to build efficient and scalable UI and be efficient with your users. Building Android user interface can be challenging, but it's also one of the most rewarding parts. Being a user interface engineer means that you are building user-facing products and you meet your users, talk to them, observe how they use the products that you build, and you can see how the products help them solve problems in their daily lives. And that is so rewarding. I hope you enjoy your role as an Android UI engineer.
As you progress through this course, you'll have the opportunity to create your own project in the development environment called Android Studio. So, let's take a moment to install Android Studio now. In this video, I'm going to show you how to download and install Android Studio. Although I'm using a MacBook, The download and installation process is similar for Windows and other operating systems. First, go to the official Android Studio webpage, developer.android.com/studio. This page has everything you need to quickly get started. It picks the operating system by default. So, because I'm running this website on a MacBook, it picks Mac OS. If you want to download on other operating systems, you can click Download Options. With this, you can choose between other alternatives for Windows, Mac, Linux and Chrome. Now, let's download the software Android Studio. Because Android Studio versions are bundled with Java Development Kit by default, you don't need to separately download and install Java on your local machine. When you click Download Android Studio, the terms and conditions are displayed, which you need to read and agree with. Then, select the correct version of Android Studio for your Mac, either Mac with Intel chip or Mac with Apple chip. The Mac I'm working on has the Apple chip, M1, so I select Apple chip. Downloading Android Studio may take some time depending on your internet speed. While waiting, it's worth mentioning that when you do create your own project in Android Studio later, you will use an emulator to run your project. An emulator conveniently allows you to simulate your app in Android Studio without needing to install the application on an actual physical device. But you'll learn more about this later.
Adrian and Mario, the owners of Little Lemon, want an app for their restaurant. They find out that you are learning about user interface and ask if you'd like to build one for their restaurant app. You think it could be a great opportunity to practice what you learn in this course. You accept their invitation and start exploring how to create a UI for Android. In this video, you will learn to define what an activity is and identify important aspects related to activities as they are essential for creating apps for Android. When you launch an Android app on your smartphone, the app shows a screen that you start interacting with. You normally find several elements on the screen, such as different kinds of buttons, labels, text fields, images, and so on. All of these make up the app's user interface. An activity is the app component that contains the user interface and represents the app screen. For example, when you are creating a user interface for the Little Lemon restaurant app, there will be a screen with a list of dishes and some other elements, like buttons and some navigation elements. That whole screen is an activity, and it contains that user interface. When you tap a dish on the list, another activity starts showing a new screen displaying the details for that dish, such as ingredients, how it's prepared, price, and possible customizations. That new screen is an activity, and it contains that user interface. It means that your Android application starts by first creating an activity. If you're familiar with Kotlin, you will note that in case of normal Kotlin programs, the main method is the program entry point. To understand activities better, let's talk about a few things that you might relate to, based on your own experience of using an Android phone. The apps we normally use on our smartphones have multiple screens, so they also might have multiple activities in them. The first screen that appears after an app is launched is known as the main activity. In the Little Lemon app, for example, the screen with the list of dishes is the main activity. Depending on the actions you take in an app, you may move around between screens to perform different tasks. For example, tapping a dish in the list starts another activity to show the details for that dish. Besides moving around, or better say navigating between activities or screens in the same app, you can start up activities belonging to other apps. For example, while browsing the Little Lemon app, there may be an icon that launches your favorite social media app to share a dish that you like. You might have noticed that the dish list and the dish details screens present different content to the user and let them perform tasks that are closely related to the content on that screen. The activities are therefore considered to be self-contained and largely independent of other activities. Since you can move around between activities, you might guess that activities can be linked to one another, and there is a mechanism to ensure that the system doesn't lose track of your navigation. We'll talk about this later. Whenever you start building an Android app, the first thing you do is to write code to implement the activity. But how is an activity represented in code? In Android Software Development Kit, or SDK, every activity is an instance of the activity class. The activity class is responsible for creating a screen or a window which contains the user interface. The activity you'd implement in your app would be a subclass of the activity class. Note that you would not extend or inherit directly from activity class. Rather, you'd extend from one of its subclasses, for example, app compat activity or component activity. But don't worry about that at this point. We will explore that later in this course. To use activities in your app, you must register information about them in the manifest. Recall that the app's manifest is the file which declares all app components and permissions. There is a lot more to activities that we'll learn in this and later courses. For now, let's keep a word of caution in mind. Development with multiple activities can become complex, and we have to be careful when defining more than one activity. And this is where Jetpack Compose, the latest Android UI toolkit, comes to the rescue by simplifying many of the tasks of UI development. In this video, you'll learn to define that an activity is the app component that contains the user interface and represents one screen. You also learned to recognize some important aspects related to activities. You now know how important it is to have a good understanding of activities in Android development. Good work. You learned what an activity is. As an aspiring developer, it is important to learn how to define an activity because understanding activity is the gateway to learn Android app development. In this video, I will create a very simple app for the Little Lemon restaurant to demonstrate how to define an activity in Android Studio using Kotlin. I have Android Studio open. To start creating my app, I click New Project on the top menu bar. Then I scroll down to select Empty Activity, since I want to define a very basic activity. I click Next. Then I name the application Little Lemon. Note that the package name updates to Little Lemon automatically. Android app's package name uniquely identifies my app on the device and in the Google Play Store. The save location is where my source code is stored, and the programming language I use is Kotlin. Android SDK is a software development kit required to develop Android applications developed by Google for the Android platform. I will use API, or Application Programming Interface Level 21, which means the app will work for more than 98% of the devices. Finally, I click Finish. Android Studio creates a simple Hello World application. It takes a bit of time to generate the code, import the necessary files, and build the project for the first time. It's finished. Now I want to check what code is generated and built. I click the Run button, the green triangular button on the toolbar. This will show the output on an emulator, also called Android Virtual Device, meaning it simulates an Android device on my computer, instead of using a physical device. I need to wait while it's loading, and since this is the first time I run it, it may take a while. Emulator is now loaded. The generated code of the app outputs the text Hello World in the middle of the screen. Now let me start creating my Little Lemon app. I want to start from scratch, so I click on the Emulator tab on the right vertical tab bar to minimize the emulator. On the left, there is the Project Explorer tab. If it is not open, you can click on the left bar to open it. I go down to the RES, or Resources folder. Then I go to the Layout folder and open the activity_main.xml file. It brings up the design preview. I minimize Project Explorer because I don't need it now. Here is the design preview. There are 3 tabs on the top right: Code, Split and Design. When I click the code, it displays the XML code of the UI. Design displays the design preview, and Split displays code and design side by side. Let's go back to Design. By default, it displays the design preview and blueprint view side by side. The blueprint is a simplified outline view of the UI and is useful when editing complex layouts. I don't need that right now, so I remove it by clicking the blue button next to the file name on top and selecting Design. This clip can be shorted to fit the script. There are 2 panels on the left side. The top panel is the palette. Currently, I only see the common UI elements. I can drag and drop these components from here onto my design. Whatever I add to my design appears in the component tree panel below the palette. It already contains a constraint layout with the Hello World text view. Now I click the Code tab to explore the code. There is an XML representation of the text view inside the constraint layout. Remember that the output displayed by the generated code displayed the Hello World text. That text is defined by the Android text property in line number 12. Let's change this text to Little Lemon. When I go to Design, the preview displays Little Lemon. Let me close the Attributes panel since we don't need it now. Let's now explore the main activity's Kotlin code. I will open Project Explorer again. The main activity is located under the app, under the Java, and under the package name I entered while creating the app. Then I double-click the main activity file. I minimize the Project Explorer. The main activity class inherits from the app compat activity. Within the main activity, there is a definition for the onCreate function. OnCreate must be defined in the main activity since program execution will start from the onCreate function only. On line number 9, there is the setContentView method. It takes the XML layout as the parameter. The parameter passed is r.layout.activity_main, which is the layout file in which I changed the text to Little Lemon. Any activity defined in the app must be declared in the manifest file. It lists information about my app and the required permissions. Now, let's open the Android manifest file. In Project Explorer, I go to the manifests folder inside the app folder. I open the Android manifest.xml file. Now I minimize the Project Explorer. My main activity is declared between lines 15 and 27. In this video, you learned how to create a very simple app for the Little Lemon restaurant. You also learned how to define an activity in Android Studio using Kotlin. In the traditional Android UI, a view is a single UI element, sometimes also called a widget, which is drawn and shown on the screen and with which a user can interact. In this video, you will learn to define what views and layouts are in traditional Android UI. You will also learn to recognize common view and view group classes. In the Android SDK, a view is represented with a class named View. It is the parent class of all kinds of views. It defines the basic building blocks for any user interface component or element. All the classes that represent specific UI elements inherit from View. For example, Text View, Text Field, Button, and Image View, to name a few. A user interface is a collection of views, organized or laid out in a well-defined manner. For proper organization, views need to be grouped and contained together. For example, in a login screen, the username label text appears right before the input text field, so we may want to group these 2 elements together. To enable such grouping and layout of elements, Android defined a container element called viewGroup. View groups are a special kind of view that do not have an appearance of their own. They are invisible UI elements which act as containers to other views or view groups. This way, the structure of the user interface becomes hierarchical, which can be represented as a tree. A view group is represented by the viewGroup class in the SDK, which is a subclass of view, but is the parent class of all individual view group types, or the layouts. Some common view groups include relative layout, linear layout, and grid layout. A relative layout specifies the position of contained views relative to each other. For example, you can place a view to left or place it below another view. A linear layout linearly organizes the contained views horizontally or vertically, as a single row or a single column, respectively. In most cases, you do not instantiate view or view group classes in the Kotlin code. Rather, you declare your UI in XML. It helps to keep the presentation of the app from the behavior defined in the code. The XML elements correspond to the view subclasses, which define the individual views or layouts, while the attributes of those elements correspond to the object properties. Now, let's go to Android Studio and define a simple UI for Little Lemon using common views and layouts. You learned that an activity is the app component that contains the user interface and represents the app screen. In this video, you will learn to use some common views such as text view, edit text, button, and image view, and their properties. You will learn how to define sizing units. Finally, you will learn to use some common layouts such as linear layout, relative layout, grid layout, frame layout, and their attributes. It is important to learn about views and layouts so you can create functional and beautiful UIs. To demonstrate these, I am going to create a basic user interface for the Little Lemon app. The UI will have a title, an order button, and an image. Let's start with the simple Little Lemon Android application created previously. I want to remove constraint layout, which is a bit complex for us at the start, and replace it with a simple linear layout. Let me remove the text view as well. For that, I click Text View in Component Tree and press Delete on my keyboard. Next, I right-click on the constraint layout in the component tree and select Convert View. A new window appears where I select Linear Layout and click Apply. The constraint layout is changed to Linear Layout. The orientation is horizontal at the moment, but I want to change it to vertical. I right-click on Linear Layout and then select Convert Orientation to Vertical. The first thing I want to do now is to add some text. Before I start using Text View, I need to add the string resources first. I click on the Project tab on the left to open the Project Explorer. Inside the app folder, I click on RES or Resource, Folder, and then the Values folder. I click the strings.xml file to open it. There is one string listed already. The name of this string is app_name, while the actual string written between string tags is Little Lemon. I want to add two more strings. A quick way is to duplicate the existing string element and then modify it. I press Ctrl D on a Windows or Command D on a Mac to duplicate the current line. I change the name attribute to little_lemon. I duplicate this line and change the name and the actual string to order. Now I edit the second string. I name it order takeaway, and I also add the value order takeaway. String resources have been added. Now I go back to activity_main.xml and I drag a text view from the palette and drop it on the design layout. Now I click Code on the upper right to go to its corresponding text view tag. I replace the Android text on line 14 with the string resource that I created earlier. I start typing Little Lemon and I select the suggestion for Little Lemon from the string resource. I click the Design button on the upper right. I zoom in and the text has changed to Little Lemon. Now let's change the text view size by typing the size inside its tag and selecting Android text size and give the value of 32 SP. I click the split button so I can view the code and the design side by side. I've yet to add a button and an image side by side. So I go to click the design view and then the click layouts in the palette. I drag and drop the linear layout horizontal from the palette to the component tree below text view. Now let's add the image. I need to go to the drawable folder under the resource folder on the upper left. I copy the image from the folder in my computer, the drawable folder, and click paste. In the new dialog box, I need to paste the image in both directories that appear. So I select the drawable folder and repeat the process to paste the image onto the drawable v24 folder also. I keep the same image name and click OK. Now I want to change the height of the inner linear layout. I click the code button on the upper right, and in the linear layout tag, I change the layout height to wrap content. If I keep it match parent, it will take up the whole screen. Now, before I add a button and then the image, I go back to Design View. In the palette on the left, I select Common. Then I click Button and I drag and drop a button under Horizontal Linear Layout in the component tree. The button appears below the little lemon text. To add the image, I drag and drop the image view below the button in Linear Layout in the component tree panel. It asks me what image I want to add. I select the restaurant food image and click OK. The image takes up lots of screen space, so I need to adjust the width and the height of the image. I go to XML code and inside the image view tag, I set the width and the height to 100 dp. In the button tag, I replace the button text to order string resource. So I just created a very simple user interface. In this video, you learned how to define what views and layouts are in traditional Android UI. You also learned to recognize common view and view group classes. Good job! You had an introduction to activity, views, and layouts. It is now time to cover how to use views and layouts in Kotlin. In this video, you will learn to identify how views and layouts are referenced and represented in Kotlin. You will also learn how to define views dynamically. When developing an Android UI using views, there are two possible ways. The first one is to structure the UI using XML. With this approach, you would normally use the layout editor in Android Studio to drag and drop UI elements or widgets from the palette. Android Studio then generates the corresponding XML structure for you. The XML representation of a view corresponds to the relevant view classes in the Android SDK defined in Kotlin. When you build and run the app, the XML declarations are used to create the relevant view objects which are initialized with the property values defined in the XML. In Android development, this process is called inflating a UI. The layout is inflated when the setContentView method is called. The second possible approach to build an Android UI using views is to create view and view group objects programmatically in Kotlin and then link them together to form the nested UI structure. You can use this approach to create the entire UI with Kotlin, but the most common usage is to partially build the static UI in XML and generate remaining UI elements dynamically during the execution of the app. A clear benefit of this approach is that the UI can be more flexible and adaptive. For example, when displaying the list of available dishes for the takeaway in the Little Lemon app, we generate a list of items in Kotlin depending on how many food items are available and what type of food items the user selected. If the user is looking for desserts, we only show the list of available desserts. Let's say we have a vertical linear layout defined in the Activities XML with some common properties. The layout is assigned an ID named Top Layout, so that we can access this layout later on. In order to add a Little Lemon text to the UI, we first ask the Android system to give us the reference of the linear layout object by providing the ID that was defined. The R is an auto-generated class that contains definitions of all resources of the application. It is where the system keeps the ID assigned to a view. Given the ID of the linear layout, the findViewById function will find and return the reference of the layout object. Next, you create the text view object and set its text property to Little Lemon. And finally, we add the text view to our layout. This will add the text view to the vertical linear layout at runtime. With this example, you covered how to dynamically add a single view to a layout. Adding complex views with several UI elements and keeping track of the changes that may happen during user interaction can make this approach more complex. Now let's go to the Android Studio and try to dynamically inject a view to the screen that I have created so far in the Little Lemon app. You already learned how to develop traditional view-based UI, defining views and layouts in XML. In this video, you will learn how to develop the UI, mainly using Kotlin. You are looking at activity_main.xml file, where I have a simple linear layout in vertical orientation. This is the only element I have in my XML to start with. I click on the Project tab on the left to open the Project Explorer. In the app folder, I expand Java, then the Little Lemon package name, and then double-click Main Activity. The main activity.kt file opens up. I don't have to open any other file, so I minimize the Project Explorer. I can see the regular startup code which Android Studio generates for a simple activity. The main activity, inheriting from app_compat_activity, has an onCreate function. There is a setContentView function called inside onCreate, which takes the XML layout and sets it on the screen. To get started with building the UI in Kotlin, the first thing I need to do is to get a reference or a link to the linear layout so that I can add views to it in my Kotlin code. To do that, I need to assign an ID to the linear layout that I in the XML. So, I go to the XML file and within linear layout, make a new line. I type ID, select the first option, Android:ID from the suggestion, and hit Enter. The cursor is within double quotes, and I'm getting two suggestions here. I select the first one since I'm going to define a new ID. After /symbol, I type top layout as an ID. You can name it whatever you want. I go back to the Kotlin main activity file. Above onCreate, I declare a late init variable of type linear layout, which I name top layout. I could give it any name, but since I'm going to use it to refer to the linear layout, I keep the same name for convenience. Inside onCreate, I initialize the top layout variable with a call to find view by ID function. This function takes a view ID as an argument, so I provide the ID of the linear layout, which I defined in XML. So type r.id.topLayout. When this code will run, the top layout variable will have the reference to the linear layout object, which was created during the call to setContentView. Now I create a text view. I set it with the resource string that was added in the previous lesson, r.string.littlelemon, using resources.getText function. I run it to see the output till now. It is showing a blank screen, although I created the text view. It is because I have not yet added the text view to the linear layout. Let's do that. In this code, the top layout variable is the linear layout. To add the text view I created to this layout, I call the addView function, pass the text view variable to it as argument. This time, when I run it, I can see the Little Lemon text. I go back to the XML file, and you can see it does not contain the text view, since I added it programmatically using Kotlin code inside onCreate function. I can create and style the UI using Kotlin. Let's change the background color of the linear layout. I go to a new line and call the function setBackground on the top layout. To pass in the color value matching the Little Lemon style guide, I call parseColor function on the color object and provide the color hex code #495E57 inside the parenthesis. Let's run and see the output again. The background is changed to hex 59E57 color, matching the Little Lemon brand. I can also change the text color of the Little Lemon to match the Little Element brand. Guidelines call text view .setTextColor function and pass in the hex color value #F4CE14 for the text in a similar manner as I did for the background color. Let me zoom in the emulator to show that the text color has changed. That's how you create a very simple UI in Kotlin. You now have a good idea that defining this UI in XML would have been a lot easier. In this video, you learned to identify how views and layouts are referenced and represented in Kotlin. You also learned how to define views dynamically. Good job. You learned that in Android, an activity represents a screen. It is also one of the most important components of an Android application, since it is the program entry point. But did you ever wonder about the life cycle of an activity? As an aspiring developer, it is important for you to know what happens when an activity is launched, when it's terminated, and what happens in between. In this video, you will learn to define what an activity lifecycle is and identify its core states. You will also recognize what lifecycle callbacks are and identify what happens when they are executed. In programming, lifecycle refers to the states a computer program goes through from initial creation to execution and eventually termination. Similarly, an activity lifecycle refers to different stages or states the activity instance goes through from the moment an app starts until it exits or gets terminated. For example, when a user launches the Little Lemon app, an activity is created. The system then sets the activity's content view and then builds the UI by creating the views and layouts. As soon as the activity becomes visible on the screen, it is in the started state. So, when it gains focus and is ready for the user to start interacting with it, it is called resumed. This is the state where the user is actually using the app. It is the state in which the activity spends most of its time. After the user is done with the activity and attempts to exit the app, the activity is first paused and it is no longer in the foreground. After this, the activity is stopped and is no longer visible on the screen. Finally, the activity is destroyed. This is a high-level and simple description of the activity lifecycle based on a simple scenario. There are some peculiar scenarios as well, which you will explore later in this course. With the activity lifecycle in mind, let's now see how activity class supports the lifecycle. The activity class provides a number of special functions, or callback functions, which are called by the Android system during different stages or states of the lifecycle. These callbacks are also referred to as lifecycle callbacks, are named after each state of the activity lifecycle. So, it is easy to remember which method gets called while transitioning from one state to the next. Let's cover what the lifecycle callbacks are. The onCreate function is called when the activity is first created. It is the most important callback since it is responsible for the basic startup routine. That is, building your app-specific UI, loading initial data, or restoring configurations. Next, onStart is called right after onCreate. Upon this callback, the activity is first visible to the user. However, for the screen to get focus and ready for user interaction, it needs to quickly proceed to the next callback. The onResume callback happens next. It ensures that the activity is in the foreground. The system does not proceed to the next callback and waits for user actions. The onPause callback is called when the activity loses focus, either because the user is leaving the activity or due to some other event like some dialogue gaining focus. If the user action causes the activity to gain focus again and become fully visible, the system calls on resume again to make the activity return to the resumed state. The onStop callback is invoked when the activity has completely lost visibility and is coming to a stop. This can happen, for instance, when a user switches to a new activity, moves to the device home screen, or turns off the screen. Finally, onDestroy is called just before the activity is fully destroyed. This can happen when the user completely dismisses the app. It can also happen when the screen orientation is changed. For example, when the user rotates the screen from portrait to landscape orientation. Change in screen orientation is also referred to as a configuration change. It is important to note that when configuration change happens, the Android system destroys the activity but then recreates a new instance of the same activity and tries to restore the state in which the activity previously was. For example, if the user had scrolled down to a particular item in the list, the newly created instance of the same activity should show the list in that specific item. When you define your own activity, it inherits the lifecycle callbacks from the activity class. You do not need to override these callbacks except for the onCreate function, which you must override to provide your own specific implementation. It is important to remember not to call these callback functions in your code. They are automatically called by the Android system for you at the right time and in the specific order as the activity proceeds to different states of its execution. There are many subtleties related to the life cycle, which you will learn about as you progress in this course. In this video, you learn to define what activity lifecycle is and identify its core states. You also learned to recognize what callbacks are and identify what happens when they are executed. Good job. You explored the basics about activities, views, and layouts. And you can't wait to learn more about Android development to work on the Little Lemon app for Mario and Andrew. You hear about Jetpack Compose, a new and modern UI toolkit, and you want to find out how it can help you create the Little Lemon UI. Compose is the preferred library for UI development nowadays. This is why it is important for you to learn how to use it to build Android UIs. In this video, you will learn to define what Compose is and to represent UI elements in it. Then you will learn to describe imperative and declarative approaches to building a UI. Finally, you will learn to differentiate between the traditional view system and the new Compose library. Android is evolving, and part of the excitement to become an Android developer is that there is always something new to look forward to. New and improved libraries provide developers with the latest toolkits to not just improve their productivity, but also to enhance the user experience. Android has introduced a collection of libraries called Jetpack. Jetpack focuses on helping developers to not only reduce development time and write less code, but also to help them in following best practices. Compose is a library for developing UI and is part of the Jetpack suite. Earlier, you covered activities and a brief introduction to building UI with views and layouts. Using views to build UI is the traditional approach. For the rest of this course, you will switch your focus to UI development with Compose, which is a new and modern UI toolkit. Using Compose carries numerous advantages over the traditional view system. Before you explore Compose, it is important that you understand why Compose is the preferred library for UI development nowadays. One of the fundamental differences between the traditional view system and Compose is their development philosophy. The view system follows the imperative approach, while Compose is based on the declarative approach to building UI. But what do these two approaches mean? The imperative approach to UI development requires that you define step by step how to build the UI. For instance, you define your views as much as you can in XML. You focus on what they should look like, rather than what data they will present. When the data will change, which almost always happens, you again define the logic step by step to update the UI. This can quickly become complex when changes are frequent or when several views need to be updated consistently. And it can get even more complex when the activity lifecycle events happen, where the activity may pause or need to be restarted or recreated. That can make even an experienced developer write code with caution. The declarative approach, on the other hand, focuses on what rather than how. You give priority to what you have to show, meaning the data. You pass in the data to the declarative system, and it gives you the UI displaying that data. Now, this doesn't mean that you no longer need to worry about designing the UI in a declarative approach. You still define what individual UI elements will look like and how to organize them together. But that definition is highly dynamic and data dependent. In other words, you say that the UI is the function of the data. But don't worry about this now. You'll understand it better as you progress and discuss some examples later. Remember, you covered view hierarchy and how views are nested using layouts or view groups to build the UI. In view system, this hierarchy is based upon inheritance. Each UI element in a view system is a view, which means it is a child of view class. Inheritance based on structuring can become complex, since you have to place all the commonalities to the root. The view class, which is the parent class for all views in the traditional view system, has around 30,000 lines of code. Even if you consider that only half of the lines are pure code, ignoring code comments and blank lines, this is still huge. You don't need to be a guru of software design to realize that this would be difficult to maintain, and doing bug fixing or extensions would not be an easy task. Compose takes a different approach. In the case of Compose, each UI element is represented through a special function called Composable. A composable function can only be called from within another composable. In Compose, the hierarchy is built through composition. A composable, as the name suggests, can be composed within another composable. So, by orderly composing composables, which represent the new UI elements, the UI can be easily constructed. In this video, you learn to define what Compose is and to represent UI elements in it. You also learn to describe imperative and declarative approaches to building a UI, and you learn to differentiate between the traditional view system and the new Compose library. Good job. Now that you have covered an introduction to Jetpack Compose, it's time to explore how you can use it to create the Little Lemon app by building a very simple UI. In this video, you will learn how to define composable functions and recognize some of their characteristics. You will also learn to develop a simple UI in Compose using Android Studio. We'll start by developing the Little Lemon home screen step by step. We'll do it by defining simple functions called composable functions. There is no need to define any XML, since everything will be defined in the Kotlin program. You can immediately recognize one benefit in that you don't have to manage the code about a single element across different files. To write a composable function, you add the @composable annotation before the start of the function definition. Let's define a composable function and call it main panel. It takes in a variable called name of the string type. Inside the main panel function, the name argument is passed to another function, text, which is a built-in composable function in Compose library. It is responsible for creating the text UI element that appears on the screen. Remember that composable functions are only called from within another composable. Since the main panel function is a composable, you could call text composable from within it. Let's explore the activity code. The main panel composable is called within the set content block of the main activity. The main activity inherits from component activity, which is the base class for activities that enable composition in Compose. Recall that composition is the process of initially generating the hierarchy of UI elements. Within the onCreate callback, there is a set content block, where the composable functions are called to construct the UI. The definition within this block is the Lambda function definition. This is all that you need to run your app. No more XML or finding views in code to update the UI. It's important to note that composable functions typically take data input as an argument, but they do not return anything. The UI hierarchy is very simple. The main panel composable emits only a single UI element, but it is common for composables to emit several UI elements. Soon, you will be writing composables like that. For now, let's go to Android Studio, develop a simple UI and run it in the emulator. I'm going to start a new project using Jetpack Compose. I click on New Project button at the top right. The New Project window has appeared. I scroll down and select Empty Compose Activity. Then I click Next. I type Little Lemon in the application name field. I keep the rest of the options unchanged. Then I click Finish A simple Hello World Android application based on Jetpack Compose is created. Since this is a new project, it is being configured and built, so it will take some time to load. The project has been built. The left side of the window is the Project Explorer. The Kotlin file mainActivity.kt is open and displays the activity code on the right side. Let's explore the file content. It starts with a package name at the top. Then there is an import section. And finally, the definition of the main activity class. The main activity is inheriting from component activity class. The onCreate function of the activity contains the setContent block, which defines the activity content. It is where the composable functions are called or defined. Within the setContent block, there are several elements such as a theme in line 19, surface container or layout in line 21, a modifier and theme color definition in line 22 and 23 respectively. All of these elements will be discussed later in the course. For now, I remove these auto-generated code elements in order to keep things simple. There are several imports which grayed out since those are not in use anymore. I press Ctrl-Alt-O simultaneously to optimize the imports. Only in-use imports are now remaining in the import section. Coming back to the setContent block, I want to add a simple text composable. As I type TE, the auto-suggestion pop-up appears, from which I select the first text option. This action adds a call to the text composable function. Inside text, I define the text property within the double quotes and type Little Lemon. That's all I need to build a very simple Little Lemon app. I run this in the emulator. The Little Lemon text appears in the top left of the app screen. I want this text to be a bit bigger, so I type comma before closing parenthesis in line 12 and start typing font. From the suggestions, I select font size and hit Enter. After equal sign, I type 32.sp. I hit Alt-Enter to import sp. I rerun the app and see that font size has increased. To change the color of the text, I type color and take it to the new line. After equal sign, I define a color object and set the color value to 0 times FFF4CE14 to match the Little Lemon style. I run the app to see that the color has changed. In this video, you learned how to define composable functions and recognize some of their characteristics. You also learned to develop a simple UI in Compose using Android Studio. Good job covering an introduction to Composable UI. You are making progress towards getting the knowledge you need to create the Little Lemon UI for Mario and Andrew. You had an introduction to Jetpack Compose and how to build a UI with composable functions. But as a developer, it's important to know how to arrange different elements in a UI. In this video, you will learn to identify basic layouts in Compose and to combine them to build simple UIs. You may remember layouts from earlier. They are UI elements that are not themselves visible but act as a container to the UI elements. They are the guides in organizing and arranging other UI elements on the screen. Layouts may contain simple UI elements as well as other layouts. Therefore, it is possible to generate a UI with complex arrangement of elements by properly nesting layouts. In Compose, every UI element is a composable. Layouts are composable too. There are several built-in layouts in Compose, and placing composables in those layouts can be fairly simple. The three most commonly used simple layouts include row, column, and box. Let's explore them now. Row lays out composables horizontally, while column places them vertically. The position of the composables within a row or a column relative to the main axis is defined through the arrangement property, whereas position relative to the cross-axis is defined through the alignment property. For a row, the main axis is the horizontal axis, so you can set the horizontal arrangement. And for the cross axis, which is vertical, you can set the vertical alignment. Similarly, for a column layout, you can set the vertical arrangement and the horizontal alignment. On the other hand, the box places composables on top of each other. When in a stack fashion, the composables of different sizes ensure they are properly visible. For example, you can place a small icon over an image. Although row, column, and box are fairly basic layouts, they are the building blocks for easily defining your custom and more specialized layouts. By default, row, column, and box are just as big as their content. However, they can be adjusted to make them larger. You will cover that later. First, let's see some layouts in action. Let's start with the Little Lemon app that we created previously. The set content inside the main activity carries a simple text composable with the font size of 32 SP and the yellowish color. I'm going to add one more text element by duplicating the Little Lemon text composable. For the second text, I set the text property by getting the string resources that were created earlier. I select string resource and type r.string.chicago as the argument. Let's revisit the resources in the strings.xml file. I open the Project Explorer and go to App, then Res, and then Values folder, and double-click on the strings.xml file. There are 5 strings to find in here. The first one is the app_name, which is added by default based on the application name chosen at the start of the project. Then there are 4 strings which I had to find, including the order string, the Chicago string, and the description string, named description1. Coming back to the main activity Kotlin file, I run the app. Both text elements are overlapping because I have not added any layout in my Compose UI yet. I have to add a column and move both text composables inside of it. So I type COL and select the column from the pop-up. I then select both text composables and drag them inside the curly brackets of the column. I run it again and the issue has been resolved. I have added a column where elements appear vertically. I now want to add a row to align elements horizontally. I do that by typing row. Inside the row, I am going to add a button and an image. I start typing select button from the pop-up and press enter. Then I add a text inside the button. I set the text using string resource and providing the ID of the order string by typing r.string.order. Next, I add the image by typing and selecting image. I define the painter property by using the painter resource, which can load a drawable resource. I then provide the ID of the image from the drawable resources, which is r.drawable.restaurantfoodb. I keep the content description empty. Let's run it. The UI elements are there. Excellent. Position, size, and style of the elements need to be adjusted. I'll do that later. In this video, you learn to identify basic layouts in Compose and to combine them to build simple UIs. Good job. Now that you know about composables and layouts, let's discuss a bit more about how to go from screen designs to nesting composables in order to build UI in Compose to apply them in the Little Lemon app UI. In this video, you will learn how to organize and nest composables to build UI hierarchy. You have developed screen designs and wireframes which capture your idea about the UI you will be building for the Little Lemon app. The designs contain the positioning and organization of the UI elements, the colors, the text styles, bordering, and shapes. The designs you created are impressive, and you want your UI to be implemented in a similar fashion. While you are learning the Compose toolkit, you can develop a hierarchical view of how to nest composables. The home screen for our Little Lemon Takeaway app has 2 portions. The upper main panel with a background color and the lower list panel of weekly specials. By looking at the wireframe for the upper panel and the type of UI elements, you decide on the hierarchy or nesting to implement the panel. To implement the upper panel, we define a composable. Let's call it upper panel. We see that the panel design stacks up UI elements vertically, so we use a column layout. We assign the Little Lemon background color to it. We then place Little Lemon and Chicago text composables in the column. The organization of the other remaining 3 elements suggests that we start with a row and add 2 elements to it. One will be a column and the other will be an image composable. The column would contain 2 elements, a text for the introduction and an order takeaway button. This organization or nesting of composables can be represented with a tree structure, where the upper panel is the topmost composable in this structure, also called root of the tree. Similarly, you can build the UI tree for the individual menu item. The lower panel of the home screen contains several menu items. Each of those has the same structure. Therefore, you should build the menu item composable in such a way that we don't need to redefine every menu item. Rather, we define only once and reuse it for every menu item in the app. Now let's start developing these hierarchies in Android Studio. In this video, you will learn how to apply some styling to the button and to position UI elements. I'm going to start with the application I created previously, but without the image to keep it simple. The emulator displays the current output of the app, so I go inside the button composable to add the styles. I add a new line under the onClick attribute and type border equals border stroke. I give it a 1 dp border stroke and set its color to red. Let's see how it looks in the output. So I run it. I zoom in to check if the border has been applied. The button has a red border now. I'm now going to change the shape of the button. So I type shape and select the rounded corner shape. I need to set the radius, so I use 10 dp. When I run it, the button corners are rounded. Next, I change the button color. To do this, I type color equals button default.button colors. Inside the brackets, I select background color equals color.gray. I run it again to make sure the output is what I want. The button color has changed to gray. I now want to change the position of both of the texts and the button to the middle of the screen. For that, I must first change the size of the column layout. Currently, it wraps its contents. I will use a special object called Modifier. You will learn about modifiers in greater detail in another lesson. For now, I'm just using one to tell the column to make its width and height to the maximum. So I go inside the column and just type modifier.fill max size. When I run at this point, there is no change because I need to define the arrangement and alignment properties of the column. I set vertical arrangement to arrangement.center. When I run it, it makes the contents of the column vertically centered. Then I define the horizontal alignment property and set it to alignment.center horizontally. Running this shows that this property horizontally aligns the column contents to the center of the screen. In this video, you learned how to organize and nest composables to build UI hierarchy. Good work. You reached the end of this module where you explored how to create a basic user interface in Android. In this module, you had an introduction to creating a UI in Android. You also covered the concepts of activity and views. Then you started learning about Composable UI and progressed to study layouts in Compose. It's now time to recap the key points you learned and skills that you gained in each of these areas. You began the module with an introduction to creating a UI in Android. Following the completion of this first lesson, you now can describe how mobile UI is built, identify unique challenges for Android UI, and set up Android Studio. So you can use it throughout this course. Following the introduction to creating a UI in Android, you started learning about activity and views, two important concepts in Android development. Now that you've covered activity and views, you can describe what an activity is, define an activity in a simple example with a single view in a layout, identify some common views, and discuss the use of sizing units. You also learned how to identify some common layouts, such as linear layout, relative layout, grid layout, frame layout, and some of their common attributes, and discuss how XML can represent hierarchies. Still in this lesson, you learned to work with the layout editor, the toolbar, the attribute pane, component tree, and the view modes, design view and code view. Identify how views and layouts are represented in Kotlin, and discuss the activity lifecycle. In the next lesson, you had an introduction to Composable UI. Now you can differentiate between the traditional view system and Jetpack Compose, discuss the problems in the view system using XML, and build a UI with Compose, using UI elements as composable functions. You also covered how to define annotations in Kotlin, describe what the composable is, and preview appearance using the preview annotation. Finally, in the last lesson of this module, you explored layouts in Compose. You now can describe layouts in Compose, such as row, column, and box layouts, and create a simple design with text, image, and button. You're now familiar with the basics of UI creation in Android. You're able to create a UI using Jetpack Compose. Excellent. You've made great progress. You've made great progress learning about all the basic elements you need to create the Little Lemon UI for Mario and Andrew. You previously learned about activities, views, composable UI, and layouts in Compose. In this module, you will learn more about building your UI with Jetpack Compose. Let's explore what you will learn in this lesson. In this lesson, you will be introduced to modifiers, what their purpose is, and also explore modifier chaining and why their order is important. Let's start. Modifiers, as the name suggests, allows you to modify some aspect of a composable that is either related to its appearance or behavior. They let you augment or expand a composable beyond its inherent capabilities. For example, a text composable can let you define the font color by defining its color property. However, to add a background color, you'd need a modifier to augment its appearance. When augmenting appearance, modifiers act as decorators. This means that they decorate or style the UI elements or composables. A modifier can, for example, modify the size, position, spacing, color, or even visibility of composables on your app. Modifiers also allow you to impart specific interactivity or behavior to the elements. For example, you can make an image or a text clickable using modifiers. You will learn more about this later in the course. For now, let's focus mainly on your app's appearance. Modifiers are essentially Kotlin objects. If you want to create a modifier instance, you have to call one of the modifier class functions. In Compose, each composable has an argument, called a modifier, which is set when defining the modifier. Let's first explore a simple padding modifier. This modifier adds some space around an element. In this example, you set the modifier argument by calling the padding function on modifier. This modifier will add a spacing of 10 dp around all four sides of the text composable. If you want to, for example, add different padding to specific sides, you can define spacing for each side separately. This way, you can add, for example, a spacing of 5 dp to the left and right and 10 dp to the top and bottom of the composable. In this simple example, you applied the padding modifiers directly to the text composable. However, since UI elements are typically placed within a layout composable, you usually add padding modifiers to the layouts. For instance, to get the same spacing around the text, you could create the composable like this example. When styling your Little Lemon UI, you typically want to apply several decorations to your element. For instance, based on your Little Lemon app designs, you may want a spacing of 10 dp, a height of 40 dp, a light grey background, and the position to be horizontally centered on the screen. This would result in several calls to the modifier. To facilitate a concise Kotlin code, modifiers can be chained together, calling each modifier function in turn, chaining them all through a dot. For example, you can have a height modifier to set the height of the composable to 40.dp. It does not include the padding. The background modifier sets the color of the composable to light grey. It can be set using the built-in color or the material theme colors set in colors.kt file. By default, the layouts wrap their children. Without defining the width or size modifiers, the row layout in our example would be as wide as the text held by text composable. Using the fill max width modifier, you are expanding your row to be as wide as the width of the screen. When you click the preview button, your UI displays with the padding, the height, text composable, and row composable filling the max width. Now that you know that modifiers can be chained, it is important that you consider the order of applying modifications. Changing the order may have a different effect on the overall arrangement, positioning, size, or even behavior of the elements. Now let's slightly modify the Say Hello composable, this time defining a fixed size for the row and make it 100 dp. Click the preview button to view the effect of modifier ordering 1, 2, and modifier ordering 3. In these examples, the modifiers are applied from left to right. Now that you know what modifiers and modifier chaining are, and also explored why their order is important, you may be able to use it in the Little Lemon app that you are creating for Adrian. Well done. As you learn more about building a UI with Jetpack Compose, you get more prepared to create the Little Lemon Restaurant app UI. In this video, you will learn how to use basic modifiers to apply background color and padding and change the size of the UI element in Compose. It is important to learn about modifiers, since you can use them to decorate or style a composable. I have my basic Little Lemon app open. It contains 2 text components and 1 order button in the middle of the screen. I will continue building the UI by styling the components with modifiers. To match my Little Lemon home screen design, the first thing I want to do is to position the text and button composables at the top. To do that, I modify the column properties. I change the vertical arrangement to top and horizontal alignment to start. When I run it, the components display towards the top and aligned to the left. Now I want to change the background color to match the Little Lemon theme using modifiers. The question is, where to apply the background color? Since column is the top level composable here, I add a background modifier to the column. I change the background modifier by typing a dot after fill max size modifier and selecting background. To define the background color, I pass a color object to the background modifier as an argument. The color objects to set by typing color and providing the hexadecimal color code within parentheses. I type 0xFF. 0x sets the degree of transparency, and FF means no transparency. Then I type the hexadecimal color code of the Little Lemon theme, 495E57. When I run it, the new background has changed. Now I want to change the color and size of the Chicago text as it is a subheading. I set the color to white using its hexadecimal code, and I change the text size to 24sp. Next, I want to add an image to the right of the button, so I go to the row in which the button is added. Below the button definition is the place for my image composable. On line 63, I start typing image and select the first auto-suggestion to generate the statement. I need to provide 2 arguments here. For the painter parameter, I have to use painter resource, since the image is in the drawable resource. So I type RE and the auto-suggestions pop up. I select painter resource and press enter. The painter resource demands an ID. It should be the ID of my image in the drawable. I start typing r.d and select drawable. I type dot and select the image I want from the list. The code isn't fully visible, so let's break the line before the comma. Now I run the application. The image takes up a lot of screen space, so I need to adjust its height and width. After the comma, I type height to select the required height modifier, and I set it to 100 dp. When I run the app, the image height is greatly reduced. I also want to center this row horizontally. I go to the row Composable and start typing HOR and select Horizontal Arrangement. I start typing AR for Arrangement and select Arrangement.Center. At this point, the image is not where I want it yet. That is because the current row width is equal to the width of the button and image. I need to expand the width of the row to take the full screen width. So, I go to the beginning of the row Composable and start typing max. I select the modifier fill max size. I add a comma to separate the parameters. Now, the image is aligned properly. So far, I have changed the background color, height, and width of Composables using modifiers. The little lemon and the Chicago text are too close to the left edge of the screen. I want them a little more to the right. So I'm going to add some padding to those text Composables. First, I add padding to the little lemon text component. Right after the color attribute, I type comma and press enter. In the new line, I type MOD and select the modifier attribute. Then, using suggestions, I write modifier.padding. In the parenthesis, I type ST to select the start attribute and assign it a value of 20 dp. And I do the same thing for the Chicago text. So I copy that line of code, add a comma and paste it inside the Chicago text component. When I run it, there is a padding of 20 dp at the start of the Little Lemon and Chicago texts. I notice that the Little Lemon text is too close to the top, so I want to add some padding at the top. In the Little Lemon text component, I go to the end of the padding modifier and I type comma top =20.dp. I run it and now there is padding at the top of the Little Lemon text also. In this video, you learned how to use basic modifiers to apply background color, height, and padding in Compose. In this video, you will learn to change the button color, adjust the font size, add rounded corners to the image, and rearrange the elements on the top section of the screen to align with the Little Lemon theme of your app using modifiers. This is the application UI I created previously. I now want to change the color of the button to match the Little Lemon theme, and to do that, I go to the button background color. I first delete the .gray text, add parenthesis to color, and then type 0xFFF4CE14, which is the hexadecimal code for the color from the Little Lemon style guide. I run this and see that the button color has changed. Now I want to change the position of the button so I can add the description text above it. I move the button Composable from the row and move it inside the parent column. When I run the application, the button is now added to the parent column below the image. I also want to add the description text to the left side of the image. For that, I need to place a new text Composable above the image Composable in the row. I position my cursor and start typing to select the text from the pop-up. Because I have already added the description text in the string resources, I select the string to set the text property of the text Composable. I use the resources.getString function to retrieve the description text and provide the ID of the description string resource, which is r.string.description1. Now I need to set the width, otherwise it will take the entire width of the screen and the image won't be visible when I run the app. So, in the next line, after the comma, I define a width modifier and set the width to 200 dp. I also wish to change the text color to match the design, so I set the color property to white. To make the text easier to read, I define the font size property to 21 sp. I run the application and now the UI is a lot better. But the image is not quite right, so I change the required height to 200 dp. I also want to add rounded corners to the image. To do this, I add a clip modifier that takes the shape of an argument. I start typing round and select rounded corner shape from the suggestions pop-up and set it to 20 dp. So, now the output matches the design of the Little Lemon home screen. This section of the UI that I built contains the content for the upper half of the screen of the original design. To replicate the rest of the design, I need to wrap the UI so that it only occupies the upper half portion of the screen. I define the fill max size modifier for the column so that it expands the column to fill up the entire available space, which is equal to the height and width of the screen. I do not want it to cover the height of the screen, so I change the modifier to fill max width. When I run it, the UI now covers the upper half of the screen with all the modifiers you have added. In this video, you learned how to change the button color, adjust the font size, add rounded corners to the image, and also rearrange the elements on the top section of the screen to align with the Little Lemon theme of your app using modifiers. You are very excited to learn more about modifiers and how they can change the appearance and behavior of your Little Lemon app UI. Recently, a colleague of yours mentioned the benefits of event handling and callbacks, and now you want to know how to use them to further develop your Little Lemon app's UI. In this video, you will learn more about what events, listeners, and callbacks are, and how they are defined. You may remember that one of the major uses of modifiers is to augment composables with interaction capabilities. When using modifiers, you can also create an interaction when the user taps on a UI element or performs some other action, like swiping, scrolling, or dragging. Doing an action in response to, for example, clicking a button on your app seems like a simple action-reaction kind of a task. So, you may want to know what the reaction or response to the user's action is, only when that action has happened. For example, you will only show a dialog box when a user clicks a specific element, which can be a button on the Little Lemon UI. In programming, you call a user action an event. Tapping or clicking a button, scrolling a list, swiping across the screen, dragging an icon, and long pressing a thumbnail are all examples of user events. Your response to an event or executing a certain piece of code or a function when an event occurs is called handling the event. For example, you handle a click or a tap by showing a dialog box, scrolling of a list by displaying new list items, and long press on a home screen to select an icon. Now let's explore how event handling works in Compose, using a button click. The button composable expects you to define an onClick parameter. This parameter is passed as a lambda function, which acts as an event handler. It defines the response to the button click event. Since a button is a UI element that is supposed to be clicked, Compose adds this as a default action for the button composable. Modifiers also allow you to add actions to the composables that do not support a default action. A text composable, for example, is generally not supposed to be clickable, but a button is. This means that text does not declare an onClick lambda parameter. However, you can add click behavior to a text by using a clickable modifier. An important point to remember is that you should not call the event handlers, for example, onClick functions. These are callback functions and are called by the system when the event of interest happens on a particular UI element. Now, let's do some live coding where you will use event handlers. In this video, you will learn how to add the click functionality to the Order Takeaway button in the Little Lemon app so that Adrian's customers will be able to click it and order their takeaways. You will also learn about displaying a text message using Toast. I've opened up the Little Lemon project, and this is the main activity. Inside the set content, I am calling the upper panel composable that was developed in a previous lesson. To quickly preview, I open the upper panel file, click on the split button on the top right, and hit Build and Refresh if it is not loaded automatically. The preview shows the upper panel UI. On the top right of the preview, I click the touch button to start the interactive mode. When I click on the Order Takeaway button, nothing happens. This is because the on-click handler for this button is yet undefined. Now I click on the Code button. Let's start implementing the event handler for the button. So when the button is clicked, a toast message is displayed. A toast is a pop-up message that provides feedback. The toast is displayed for a fixed amount of time without affecting the interactivity of the activity that is currently open. Inside the onClick, I remove the to-do comment and add the toast by calling the toast.makeText function. The function takes 3 arguments, which are the application's context, the text to display, and the display duration of the toast. To get the application context, I use localContext.current in the start of the upper panel Composable. I will pass the context variable as the first parameter. I then set the second parameter called text to order successful as text parameter. And now, to specify the toast duration, I used toast.length_short. At the end of the make toast, I will call the show function to display it. Let's run the app. Now when I press the Order Takeaway button, it shows the Order Successful message. Congratulations, you have successfully learned how to implement the on-click functionality of the button. You have also learned how to display a toast message, which will help you with creating the UI of your Little Lemon app. Now that you know what events, listeners, and callbacks are, and how they are defined in Compose, you can now use them when creating your Little Lemon app. Well done. Adrian and Mario, the owners of the Little Lemon restaurant, are very pleased with what you have accomplished with the Little Lemon app using modifiers. You have recently heard about how state management can improve your app's interface. Let's explore. In this video, you will define what a state is and learn why managing it is so important. You will also learn how the state is updated in the UI. In programming, state is generally referred to as the data or some piece of information of a program that changed over time. It may also refer to a current snapshot or condition of a program, which can be described as using a collection of data within the program's execution. So, it is important that the state is remembered by the app to ensure proper execution of the program. For this to happen, you use the mechanism provided by the Remember and State APIs or Application Programming Interface in the Compose library. Now, you may be thinking, isn't this why you use variables to keep track and remember information? Exactly. Variables help you to remember tiny pieces of relevant information, and this is a great way to preserve the state. However, you can also preserve the state by not just saving relevant information in the memory, but also on the disk, using file write-ups or storage in a database. So, how do you preserve or save the state? And at which point in the program execution should this happen? The answers to these questions all depend on the application. In this video, you will learn some guiding principles of preserving the state as you progress. Let's explore the state and preservation of the state of the UI and what it means. Individual UI elements such as buttons, checkboxes, text fields, and sliders have a state. A user may have pressed a button, checked or unchecked a checkbox, entered data or deleted data in a text field, or moved a slider to a new location. This state information may be of interest and should be preserved. But you may be thinking, why is that important? Because the UI needs to be recreated, and this is a common occurrence in a mobile application environment. In a previous lesson, you learned about activity lifecycle. There are situations in which an activity is recreated. For example, the changing from light to dark mode, screen orientation, or turning the display on. The recreation of any activity also causes the UI to be recreated. If a user, for example, completed a form halfway on the Little Lemon app, when the UI was recreated, it may frustrate them if all their data on the app was wiped out. This may happen if the recreation resets all the UI elements. You would never want that to happen, and that's exactly why preserving your UI state is crucial. Whatever you display to the user has a state. It is your responsibility to make sure which state you'd like to protect so that you can restore it correctly. Not everything is part of the state, which you may want to recover. For instance, if part of your UI includes a graphic with a fill of random color, it may not be necessary to restore the same color when the UI will be recreated. The recreation of, for example, the little lemon UI does not only happen when recreating an activity. In Compose, it may happen frequently and is called recomposition. Recomposition happens whenever state changes. You will explore this in greater detail in another lesson. So, typically the UI displays the state. The state changes in response to events, though most of the events happen due to user interaction within the Little Lemon app. There are events which occur without user intervention. Those are typically external events, for instance, loss of network connection, drop in the battery charge, or completion of a download. Often, you perform actions based on state changes, and usually the event handlers update the state. That updated or new state is then displayed to the user. The cycle is then repeated. Now that you know how states work, you may want to apply them in the Little Lemon app UI you are creating. Well done. Now that you explored what a state is and why it is important to remember and restore the state in the Little Lemon UI, let's address how to declare and manage the state. In this video, you will learn how Jetpack Compose defines a state. You will also find out how to declare state objects and ensure that the state is preserved across recompositions. A state is typically a variable, which can change or, in other words, mutate. Compose holds the value of such a variable in a special object called the mutable state object. So, how does this work? To define a mutable state, you call a built-in function, mutable state of, and pass in the value that you want it to hold as a parameter. The mutable state of function creates the mutable state object and holds the value. The mutable state object is a special object because any change to the value that object holds is observed by Compose. So, what is observing a value? This means that Compose will keep an eye on the value associated with the mutable state object, and whenever it changes, it will make sure that whoever reads or displays that value is notified of the change. Typically, UI elements or composables are the ones who read and display that value. However, when the value changes, the composable functions need to be recalled, which is termed as recomposition. This makes sure that the Little Lemon UI, for example, shows the correct state or value of the variable. Now, there's a catch. When the variable is defined within a composable function, then a recall to the same function would reset the variable to its initial value. This is not ideal. You would rather want to retain the value even after recomposition occurs. To support this, Compose provides a special composable function called remember. Passing any mutable state object to remember makes sure that the value is kept or retained even after recomposition. Another declaration is to use the by keyword in Kotlin. Both statements are the same, and you can use any of them. Now that you know what declaring a state is, let's explore an example of how to do this in Compose. When the user places an order using the Little Lemon app, they must specify the quantity of each item. The count of the item in an order is the state that needs to be preserved. In this video, you will learn how to maintain the state using Remember and State API. I open the main activity where the set content calls the item order composable. The item order contains a column with a horizontally centered alignment. Inside the column is a text for the item name and a row with a maximum width and center property. Inside this row are two icon buttons, one for adding an item, a text for displaying the item count, and a button for removing the item. Let's run the app. Currently, the UI is very basic. When I click the plus and minus button, nothing happens. The on-click handler for the buttons are not yet defined. To do that, I first create a count variable in the item order function. To keep track of the item count, I initialize it to the value of 0. Next, in the Add Buttons on-click, I increase the count variable using the post-increment operator. Similarly, for the minus button, I decrease the count using the post-decrement operator inside the on-click trailing lambda. I then update the hard-coded text of the text object to contain the value of count. Now, I run the app again. On clicking the buttons, the count is still not changing. It is because every button click triggers recomposition, which calls item order again, which in turn resets the count variable to 0. The UI is not yet able to hold its state across recompositions. To rectify this, I add the byRemember delegate to the count variable. It will help me to access the value without using the .value property. Inside the remember block, I will call the mutable state of function with the value of 0 to notify Compose that the value is updated. Android Studio highlighted the remember with a red line. I will go to the left of the statement and click on the red bulb. I will choose the Import Get Value in Mutable State of to import the libraries required. I will also need another import for setting the value, so I click on Remember, and Android Studio prompts you just above the Remember to press Alt plus Enter on the keyboard to import it. Let's run the app. Now the item increases by clicking the Add button and decreases by clicking the minus button. Everything is working now. You should now be able to declare and hold a state when creating the UI components in your Little Lemon app. Now that you know how states work, you may want to apply them in the Little Lemon app UI you are creating. Well done. You probably learned about recomposition when you explored how to recreate your Little Lemon UI. In this video, you will learn to explain what recomposition is and describe how Compose performs recomposition effectively. Let's first explore what composition is. When you start up your Little Lemon app and you run the composable functions you defined for the first time to produce the UI, it is called composition. In any reasonable UI, composables are usually nested together. Let's consider your Little Lemon login screen, for example. You place a text and a text field, Composable, in a row. You then stack 2 rows in a column with the Little Lemon logo image on the top and a login button at the bottom. Now the structure of the Little Lemon UI can be represented as a tree, where your Little Lemon login screen composable is at the root of this hierarchy, and the built-in composables are the leaves. The process of composition builds a tree structure, which is maintained by Compose. However, as the state changes take place, a composable function needs to be re-executed or recomposed. So, recomposition is the process of updating the composition to reflect any changes. So, if the state or some data element changes on your app's UI, does Compose recompose the whole UI? Thankfully, that's not the case. Otherwise, it would be very inefficient. Jetpack Compose intelligently spots the composables that are affected by the state change and only recomposes them. The rest of the composables which are not affected by the state change are not re-executed. This means that only part of the tree hierarchy gets updated. Let's explore an example of how recomposition works. In this video, you will learn how recomposition works and which UI elements are updated after the recomposition. I have opened the Little Lemon project, and the main activity is currently open. Inside the set content, there is a call to the item order composable, which was developed previously. I now run the app to show its UI and the functionality of the buttons for adding and removing the items. When I click the plus or add button, the items count increases. When I click the minus or subtract button, the items count decreases. It is essential to mention that currently I am using the Android Studio Dolphin 2021.3.1. In this version, a new feature was introduced, which is Compose Recomposition Counts in Layout Inspector. This feature works with Compose 1.2.0 Alpha 03 or higher. The Layout Inspector allows developers to see whether the UI element is recomposed or skipped. Knowing when composables are recomposed is important for UI debugging to ensure that the layout is implemented correctly. It means if the UI elements are recomposing too many times, then it is an unnecessary burden on the device and may cause performance issues. On the other hand, it is also problematic if the UI is not recomposing when required. Let's explore the build.gradle file to check Compose version. I go to Project Explorer, and under Gradle scripts I open the build.gradle project script. At the start of this file, inside the build script block, I see a variable compose_version, which indicates that my compose version is 1.3.1, which will support recomposition count. Now I close unnecessary files and go to the main activity file. To open the Layout Inspector, I click Tools on the menu bar and select Layout Inspector. Currently, it is not showing anything as the app is not running. So I run the app in the emulator. After the app is launched, the Layout Inspector connects to it automatically. On the left panel of the Layout Inspector, you can see the layout hierarchy under the component tree. In the middle panel of the Layout Inspector, the UI is displayed. Before I interact with the app, I want to make sure that necessary options are selected. First, I click on the Expand All button in the left panel to fully display the component tree. Then I click on the View Options button for component tree to make sure Show Recomposition Count option is selected. And I also enable the Live Updates toggle button. Now, when I press the Add button, the recomposition count starts showing up and keeps updating as I click the Add or Remove button. Notice that the count is shown only for the text composable inside the row. This is the composable which shows the item count and is the state of the item order. Recomposition for the rest of the elements in item order is skipped. Notice that when I press the Add button, number of times this Recomposables has been recomposed is increased for the text count which is displayed in black, and number of times recomposition for this component has been skipped increases for all the other elements which is displayed in grey. When I press the Remove button, the same behavior can be observed. In this video, you learned how Jetpack Compose smartly performs recomposition and how to use Layout Inspector to expose recomposition behavior. Now that you know what recomposition is and how Compose performs recomposition, you can apply them in the Little Lemon app UI you are creating. Great job! Let's start with the simple UI that you created for your Little Lemon app where you keep track of how many food items the user wants to order. The card composable you created in the previous lesson has the menu item title, a count of how many of these items are being ordered, a plus button to increase the count, and a minus button to decrease the count, and an add button at the bottom so that the user can add a menu item to the overall order. First, let's quickly revise the code that shows how the UI is arranged. I press Ctrl-Shift- simultaneously on my keyboard. When I do this, all the function or class definitions collapse. This will help you to learn and understand the code when you expand each definition one by one as you progress. When I open the main activity definition by clicking the three dots, I have an onCreate method, the main method. When I open the onCreate, I have a setContent function, which is responsible for setting the UI on screen. When I click it, I have one variable called count, which is initialized to 0, using the remember and mutable state of function calls. When I run this code, I get the initial value of the count as 0 in the output. Next, I have one column where I set the content as center horizontally and center vertically. When I open the column, I have a card inside it. Inside the card, I have a column. Inside the column, there are three composables. The first one is a text that shows the item name. The second composable is a row that has two text buttons and a text in between the two text buttons. The third composable is a button at the bottom that is named Add. So when I open the first text button, the onClick handler simply decreases the count by 1. When I open the definition for the second text button, I'm increasing the count by 1 in the onClick lambda. I've provided an overview of the code. Now, let's move to the emulator where the app is running. I increase the count a few times. Now I want to rotate the screen. I first need to make sure that the auto rotate is enabled. To check this, I swipe from top down and go to the notification panel. So, let's clear any notifications and find the auto rotate button. I check that the auto rotate button is enabled. Now, let's rotate the emulator using the rotate right button on the emulator toolbar. As soon as the screen is rotated to the right, the count data is lost. The count value, which was 3, is now reset to 0. Even though I have used remember in the code, the UI has lost its state. The change in screen orientation also caused the whole activity to be destroyed and then recreated. It is not a simple case of remembering state across recomposition. To make sure that the data is not destroyed, I need to remember the state across activity recreation. Compose provides a special function called Remember Savable to do just that. So, to avoid losing the count data, I should change remember in the code to Remember Savable when I initialize the count variable. I now go to the place in the code where I have declared the count variable in line 26. I change the keyword remember to Remember Savable and delete the parameter inputs. Now when I run the code, this issue has been resolved. When I rotate the device, the count data is correctly saved and restored by Compose. You can now save and restore state in your Little Lemon app in the same way, irrespective of the state or the screen orientation changes. You are very pleased with all the new ways you learned how to manage the state of your Little Lemon app's UI. You have previously explored Remember and Mutable State of API to preserve the state across recompositions and activity lifecycle. In this video, you will learn the difference between a stateful and stateless composable, and why making a composable stateless can be helpful. State management is an important task, and should be done in a way that makes your Little Lemon application easier to maintain. You previously learned that you should write this line of code to remember the mutable state of a value within your composable function. For example, when maintaining the count of the items for the takeaway order in your Little Lemon app, you added the line of the code within the item order composable. This means that the item order is managing its state internally. Any composable holding and modifying its state internally is called a stateful composable. In the case of stateful composables, their caller does not affect or modify their internal state. In this example, the app screen composable calls the item order, and it has nothing to do with the count in item order. However, based on the logic you use to implement the business process, there can be situations where the caller of the composable can affect its internal state. On the other hand, when a composable does not hold or modify its own state, it is called a stateless composable. The caller holds or modifies the state in a stateless composable. So, the item order would become stateless if you move the remember mutable state of call out to the app screen composable. However, there is a specific programming pattern that you can use to make such a move. It is called state hoisting. Besides business logic, one of the major reasons to make a composable stateless, or to hoist the state to the caller, is because you want your composables to be reusable. Reusability is one of the best practices to follow when defining composables. It means that you should define your composable function in such a way that, if you need a similar user interface element in your UI, you should be able to simply recall the same composable, but this time passing in the new parameters. Let's explore an example of how you can make item order reusable and stateless. To demonstrate how state management can be performed outside the composable, I have opened the Little Lemon app. Set content contains the app screen composable, which calls the item order composable, developed in a previous lesson. When I run the app, the count can be increased or decreased by pressing the Add and Remove buttons. The item order is a stateful composable because the state of the count variable is held within this function. Let's consider what happens in the scenario when the user is completing their order. You will need the item count to calculate the total bill. It is important to allow the user to be in control and let them change the count even at the checkout screen, which means that this count can change. Therefore, the state of item order can be affected outside of the item order composable. It is therefore desirable to make the item order stateless and shift the responsibility of managing the count or the state to a composable up in the hierarchy. Let's say I want the app screen composable to be able to manage the count. So I simply start by moving the variable count from the item order composable to the app screen composable. For that, I select and cut the var count declaration and paste in the app screen composable. Since the count is in the app screen composable, I need to pass the count to the item order composable, since I'm using it in the text between buttons to show the count. Even though the count is declared in the app screen composable, the button click in the item order composable is still the event that triggers the change in the count value. Therefore, I add 3 parameters, corresponding to the arguments. I add the count of type int as the first parameter. The second parameter is a lambda function that I name on increment. I then type the parenthesis arrow unit, which means this function does not take any arguments and does not return a value. Similarly, the third parameter is a lambda named on decrement. Now, in the call to item order in the app screen, I pass 3 arguments. The first argument is the count. The second argument is the on-click lambda function definition for the add button. So, within curly braces, I type count++. The third argument is the on-click lambda definition for the remove button. So, within curly braces, I type count --. Finally, I update the click lambda definition for both the buttons. I call on decrement in the remove button and on increment in the add button. Let's run the app. Both adding and removing the item in the Little Lemon UI work like they did previously, but now with hoisted state implementation. Whilst creating your Little Lemon UI for Adrian, you can now use stateful and stateless composables. You also learned why making a composable stateless can be helpful when creating your app. Well done. Developing UI with Compose is an exciting journey, and you have come a long way making great progress with your Little Lemon app. By now, you have realized that Compose is a rich toolkit that offers capabilities to develop exceptional UI designs by providing components that help you to apply standard patterns of design. UI design and development has a lot to do with a good sense of aesthetics or creativity. It helps you to follow best practices to improve your user's experience. For new designers and UI developers, it is very helpful to follow design guidelines and proven best practices. In this video, you will learn what material design and material components are. You will also discover what a scaffold is and how a scaffold can provide common layout structures. Let's first explore what a design system is. A design system represents design guidelines. It is a collection of components which carry standard and reusable UI elements. It not only informs developers on how to use and organize individual UI elements, but also exposes patterns, themes, and examples of UI designs and layouts at various levels. Material design, on the other hand, is one of the most popular and comprehensive design systems that creates impressive user interfaces. In material design, the individual UI elements are called material components, which carry a standard and adaptable look and feel. The UI toolkit Jetpack Compose can help you implement material design. Jetpack Compose makes it easy to implement the material design system to give your app a consistent look and feel. It also offers several material components that can be implemented as built-in composables. For example, button, text field, checkbox, card, and slider composables. Compose also offers common UI patterns, combining several of the material components. Now, you may ask, What are UI patterns? They are common UI design structures which you find in many apps. For example, a top app bar that carries the name of the app and some buttons relevant to the current screen. The top app bar is a UI pattern and is usually used as a composite component that consists of several UI elements. Not every app has the same design for their top app bar, but almost every app developer customizes it based on the user's needs, as you may very well do designing the Little Lemon app. Similarly, the navigation drawer is a common UI pattern found in many apps. It contains several UI elements, many of which are buttons, icons, or other clickable text elements. The drawer normally opens by clicking a button on the top app bar, or by swiping from left edge of the screen to the right. The top app bar is made up of the navigation drawer button, the app title, and the button for the basket. You may also want to use this UI pattern in your Little Lemon app. Compose provides a convenient way to combine these UI patterns and material components. It uses a special composable called Scaffold. The word scaffold is generally used in construction and refers to the flexible structures which help to support builders. In Android UI development, scaffolds are customizable layouts that provide support to add various UI structures and components, which include app bars, snack bars, the navigation drawer, and floating action buttons. Besides the main body of the scaffold, a scaffold can be configured to include some or all these UI structures. A general structure of the scaffold is defined in your code. The main screen content, or the body of the scaffold, is defined as a trailing lambda. In a previous video, you may have already learned that a trailing lambda is a Kotlin convention, when the last parameter of a function is a lambda and that lambda parameter is called the trailing lambda. The trailing lambda can be placed outside the parenthesis within curly braces. The UI structures or material components, such as an app bar or navigation drawer, can be added to the scaffold by providing arguments to predefined properties. For example, to add a top app bar to the scaffold in your Little Lemon app, you provide an argument for the top bar property by using the built-in top app bar composable. Similarly, other properties that are used to define relevant material components are bottom bar, snack bar host, floating action button, and drawer content. Once you define these properties using relevant composables, you can include them in your scaffold. You should now be more familiar with what material design and material components are, and also how to scaffold your Little Lemon UI. Great job! You are progressing very well with the Little Lemon app user interface, and your client Adrian is very pleased with the work that you have completed. You are delighted that you learned more about material design and material components, and also that Compose can implement many of these material components so that you don't have to do all the hard work. This has helped you significantly with the development of your Little Lemon UI. In this video, you will explore what content slots in the material components in Compose are. You will also learn how to implement the top bar in the Little Lemon app. Let's start. One of the key properties of the material components is their adaptability. Several of the material components that can be implemented in Compose as built-in composables are adaptable as they offer slots. Now, you may wonder what a slot is. A slot is a parameter that can accept composable content as generic lambda. The benefit is that you are free to define the inner content for the slot. For example, button is a built-in composable that is implemented as a material component in Compose. If you open the source definition of button as defined in the Compose library, the last parameter is content, which is defined as a trailing lambda, and it expects a composable definition. So, when you define a button, the definition within the curly braces is the content of the button. The beauty of this approach is that you are free to define the content of your button. You can just place text before an icon before the text, only an icon, or just an image, whichever way you prefer. The content slot allows you to provide your own definition. Similar slots are available for several other material components, which Compose implements. For example, the Scaffold defines slots for the content, top bar, bottom bar, snack bar host, floating action button, and drawer content. Here, the content slot defines the main screen UI, while the other slots would define the relevant UI structures, for example, the floating action button or top app bar. Now that we have explored how to provide your own content for the slots defined in the built-in Composables, let's define the top app bar for your Little Lemon takeaway app. Let's continue with the Little Lemon app UI I worked on previously. In this video, I will create a scaffold with a top app bar that will have a menu, a logo, and a cart icon. In the main activity file, I start by moving the column in the home screen function into a scaffold composable. I select the column and cut it. Then I create a scaffold and paste the column inside its content. Next, I pass an instance of my top app bar to the top bar property of the scaffold. This is showing an error because this function doesn't exist yet. I will create it now. In the project pane, I right-click on the package name folder. I select New in the menu and tap Kotlin class/file. I enter the file name as top app bar. Select the File option and press Enter. Inside this new file, I create top app bar composable. In the function, I will create a row and add 3 children to it. The first is the menu icon. I create an icon button and add an image to it. The image will display the hamburger drawable. For the image's content description, I pass menu icon. Next is the Little Lemon logo. I copy the image composable and paste it below the icon button. I replace the drawable with a no background version of the Little Lemon logo. Similarly, I replace the content description with Little Lemon logo. The last child is the cart icon. I will copy the whole menu icon button and paste it below the logo composable. I also replace the drawable ID with the cart drawable and the content description with cart. To preview my progress, I will create a preview composable function and call top app bar inside it. I display the preview pane and refresh it to ensure it renders the latest changes. The icons are too big, and the cart icon is not visible. I will fix this by adding size modifiers to the menu and cart icons. 24 dp should be okay. Afterward, I refresh the preview again. The cart icon is not visible because the Little Lemon logo is still too large. I will not use a fixed size modifier to fix it because I want the logo to be responsive. So I will make it 50% of the screen width. I will use the fill max width modifier with a fraction of 0.5. I will also add a padding modifier, so there's some space between the logo and the other icons. To fix this, I will add a space between horizontal arrangement to the row alongside a fill max width modifier. I will also add a center vertical alignment. I refresh the preview again. The composable is well sized and laid out. In this video, you learned what content slots in material components in Compose are, and you should also be able to implement a top bar in your Little Lemon app. Well done. In previous videos, you learned about scaffold and material components. Based on what you learned, Compose can be called a data-driven UI or state-driven UI library. This is because Compose keeps your UI updated as the data or state changes on your Little Lemon app. This means that the state changes that drive recomposition or regeneration of your app's UI elements, so that your user can then view the new data on the user interface. You now know that Scaffold is a composable, which is a material component in Compose. It provides slots to let you add or plug in other common UI structures, like drawer, top and bottom app bars, floating action button, and snack bar. In a way, a scaffold acts like a container to these UI components. In this video, you will learn what a scaffold state is and how to use a scaffold state to implement drawer actions. The state of the UI components in a scaffold can be held by scaffold state. Scaffold state is a class in Compose. It holds a basic screen state, like sizes of the components and stores, the state of the drawer, and the snack bar host. To remember the state, you call the remember scaffold state function to get a scaffold state instance and pass it to the scaffold. So, when you define the drawer state object maintains the state of the drawer, which can be either open or closed. The state can be changed by calling its public functions open or close that correspond to opening or closing of the drawer. For example, to open the drawer, you use the scaffold state object to get the drawer state object, then call open using the drawer state object. However, since open is a suspend function, the statement must be executed within a coroutine. A coroutine at a high level is a program component that takes a block of code and runs it concurrently with the rest of the code. A suspended function in Kotlin is simply a function that can be paused and resumed later. A suspended function can only be invoked within a coroutine. Launch builds a coroutine. It launches a new coroutine together with the rest of the code. A launch is declared in the coroutine scope, which is a scope for the new coroutine. Let's go to Android Studio and explore how you can add a drawer and the drawer open action to the top app bar button. In this video, with the help of scaffold state, I will add a drawer to the scaffold. I'll demonstrate how to use the scaffold state to open and close the drawer. The drawer will contain some dummy texts and an icon button to close the drawer. Let's continue with the UI created for the Little Lemon app that I am building. I open the Little Lemon project, and inside the package, I create a new Kotlin file named drawer panel. Inside it, I create Composable function, also called drawer panel. Inside this function, I generate a list of 10 text composables with dummy texts. I type list and pass 10 to the constructor. I type an open brace and start typing text, and I select text from the suggestions. I pass item $it to the text parameter. I also add a padding modifier. The horizontal will be 20 dp and the vertical will be 10.dp. After these 10 texts, I will have an icon button, which will be clicked to close the drawer. I place my cursor below the list and start typing icon B. Then I select icon button from the suggestions. I delete the dummy text in the onClick lambda and leave it empty for now. To add an icon to the icon button, I place my cursor inside the braces and type icon. I type image vector equals to icons.default.exit to app. And set the content description equal to close icon. Next, I want to make the drawer show up when the menu icon is clicked. I go back to the main activity file and declare two variables above scaffold. The first one is scaffold state, and I define it by calling the remember scaffold state function. The next one is scope, and I define it by calling the remember coroutine scope. Let's explore the source code of remember scaffold state for a bit. I control-click or command-click on Remember Scaffold State to see the source code. There are two parameters here, the drawer state and snackbar host state. Drawer state stores the state of the drawer, whether it's open or closed. It'll also be used to open and close the drawer. The snackbar host state does something similar, but for snack bars. We will explore more about the snackbar host state later. Now, back to the main activity file. I place my cursor after the open bracket of the scaffold and press Enter. Then I set the scaffold state property. I also go back to drawer panel file and add two parameters to the drawer panel function. The first one is the scaffold state of type scaffold state, while the second is scope of type coroutine scope. Then, inside the onClick lambda of the menu icon button, I call nullable scaffold state.nullable drawer state.open function within the launch builder. Back to the main activity file. I pass scaffold state and scope to the top app bar Composable. And finally, I pass drawer panel to the drawer content parameter of the scaffold. I run the app, and when I click on the menu icon, the drawer icon appears. When I click on the exit button, the drawer closes. You have now learned what a scaffold state is and how to use the scaffold state to implement drawer actions. You should now be able to implement scaffold states in your Little Lemon app. Good job. You've reached the end of this module where you explored how to build a user interface in Android using Jetpack Compose. In this module, you learned more about using modifiers and interactivity in Jetpack Compose. You also covered the concepts of managing states in Compose. Then you started learning about laying out composables. It's now time to recap the key points you learned and skills that you gained in each of these areas. You began the module with an introduction to modifiers and interactivity in Jetpack Compose. You learned that modifiers allow you to modify some aspect of a composable that is either related to its appearance or behavior, and that they let you augment or expand a composable beyond its inherent capabilities. You now know that a modifier can, for example, modify the size, position, spacing, color, or even visibility of composables on your app. You also discovered that modifiers are Kotlin objects, and to facilitate a concise Kotlin code, modifiers can be chained together, calling each modifier function in turn, chaining them all through a dot. When using modifiers in Compose, you can also create an interaction when the user taps on a UI element or performs some other action like swiping, scrolling, or dragging. You may also recall that in programming, you call a user action an event, and that your response to an event or executing a certain piece of code or a function when an event occurs is called handling the event. Following the completion of this first lesson, you now can explain what modifiers are, describe the purpose of modifiers, explain modifier chaining, and explain why the modifier chaining order is important. So you can use it throughout this course. In the next lesson, you learned more about what a state is. You discovered that in programming, state is generally referred to as the data or some piece of information of a program that changed over time, and that it may also refer to a current snapshot or condition of a program. You furthermore learned that the state is remembered by the app to ensure proper execution of the program. And for this to happen, you must use the mechanism provided by the Remember and State APIs, or Application Programming Interface, in the Compose library. A user may have pressed a button, checked or unchecked a checkbox, entered data or deleted data in a text field, or moved a slider to a new location. You now know that this state information may be of interest and should be preserved. And the reason it should be preserved is because the UI needs to be recreated, and that this is a common occurrence in a mobile application environment. You also learned that recomposition happens whenever state changes. You discovered how to declare and manage the state. You now know a state is a variable that can change or mutate, and that Compose holds the value of a variable in a special object called the mutable state object. You learned that to define a mutable state, you call a built-in function mutable state of, and pass in the value that you want it to hold as a parameter. You now also know that the mutable state object is a special object because any change to the value that the object holds is observed by Compose. However, when the value changes, the composable functions need to be recalled, which is termed as recomposition. This makes sure that the little lemon UI, for example, shows the correct state or value of the variable. You also learned that you must retain the value even after recomposition occurs. And to support this, Compose provides a special composable function called remember. In this module, you discovered that Jetpack Compose intelligently spots the composables that are affected by the state change and only recomposes them, and that the rest of the composables which are not affected by the state change are not re-executed. Finally, in the last lesson of this module, you explored how to lay out composables. You learned that a design system represents design guidelines, and that it is a collection of components which carry standard and reusable UI elements. You now know that material design is one of the most popular and comprehensive design systems that creates impressive user interfaces. You were also introduced to Jetpack Compose that can help you implement material design and makes it easy to implement the material design system to give your app a consistent look and feel. Next, you were introduced to a special composable called Scaffold, where Compose provides a convenient way to combine these UI patterns and material components. You discovered that the main screen content, or the body of the scaffold, is defined as a trailing lambda, which is a Kotlin convention. You may recall that the last parameter of a function is a lambda, and that a lambda parameter is called the trailing lambda. You also learned that one of the key properties of the material components is their adaptability, and that several of the material components that can be implemented in Compose as built-in composables are adaptable, as they offer slots. You discovered that a slot is a parameter that can accept composable content as generic lambda, and that the benefit is that you are free to define the inner content for the slot. You then learned that the state of the UI components in a scaffold can be held by scaffold state, and that scaffold state is a class in Compose. You also discovered that when you define the drawer state object maintains the state of the drawer, which can be either open or closed. And to open the drawer, you use the scaffold state object to get the drawer state object, then call open using the drawer state object. However, since open is a suspend function, the statement must be executed within a coroutine. And you may now know that coroutine at a high level is a program component that takes a block of code and runs it concurrently with the rest of the code. Now that you've covered laying out components, you can explain what material design and components are, describe what a scaffold is, explain how a scaffold can provide common layout structures, and explain what content slots in material components in Compose are. You also learned how to implement the top bar in the Little Lemon app and describe how to use a scaffold state to implement drawer actions. You're now familiar with how to build a user interface with Jetpack Compose. Well done! You've made great progress. You learned how to create a basic UI in Android for the Little Lemon restaurant using Jetpack Compose. And as you prepare to build your app, you need to learn how to create navigation to move between different screens. In this video, you will learn to define what navigation is and describe its core concepts. You will also learn to explain how navigation is used in Jetpack Compose and identify 3 major parts of navigation in Compose. A typical app consists of more than a single screen, so you need a mechanism to navigate from one screen to another. Android Jetpack provides a navigation component which makes creating navigation easier. Navigation starts with a simple action such as clicking a button or selecting an item from a list, that triggers Navigate to the next screen, also called the navigation destination. However, you can have complex navigation components that not only navigate to the next screen, but also display the status of the item selected for navigation. An excellent example of such navigation is tabs. Tabs are displayed on the top under the app bar. Another example of an advanced navigation component is the bottom navigation. It allows navigation to primary app destinations while displaying the bottom navigation item, which is currently active. Bottom navigation bar is similar to the tabs, which are displayed at the top. You will learn how to create the bottom navigation later. Now let's explore some of the core concepts of navigation. They include fixed start, up versus back navigation, and navigation through the stack. Let's cover fixed start first. The fixed start navigation principle states that the application always starts from the same home or first screen. It also states that when the user presses the back button, that same starting screen will be the last before leaving the application. In Little Lemon app, for example, when you launch the app, the home screen appears. Then you select an item from the list and the item's details are displayed. On pressing the back button from the details screen, we go back to the list screen, and after pressing the back again, we exit the application. Now, let's explore up versus back navigation. Similar to the back button, another button is available within the app for a back operation. This button is known as the up button. It is usually placed at the top left in the app bar. The fundamental goals of back and up are different. Back takes you exactly where you were within the current task stack, while up takes you to a fixed place, no matter where you came from. Next comes navigation through stack. The term stack commonly refers to last in, first out. Like a stack of books, the item which is placed on top last is picked up first. In Android, the back stack is used for backward navigation. After the application launches, the start destination is entered into the stack, and whenever another destination is opened, it is placed on the top of the stack. Adding the destination to the stack is also known as pushing. In contrast, when the back button is pressed, the last item is removed from the top of stack. This is also known as popping. In short, the back stack maintains the history of the navigated destinations, with the current one being on the top. Android navigation component supports Jetpack Compose based applications, which means you can easily use the navigation component to navigate between composable screens. There are three major parts of navigation: NavGraph, NavHost, and Nav Controller. Let's start with NavGraph. Every screen that is displayed is known as a destination in navigation. NavGraph provides the paths to the destination from the starting destination. In other words, NavGraph is a collection of navigatable destinations. Additionally, NavGraph is provided to NavHost for building the graph. Each composable destination corresponds to a route in the navigation graph. The route is a unique string for every destination. Now, let's cover NavHost. NavHost acts as a container for displaying the current destination. It takes the Nav Controller as an input parameter and associates it with the Nav graph, which contains the destinations which can be navigated. The content of NavHost is automatically recomposed during the navigation. Every NavHost must be associated with a single Nav Controller. The last major part of navigation is Nav Controller. It is an essential component for navigation that manages the back stack. Nav Controller is responsible for navigating between destinations while keeping track and manipulating the back stack. It should be placed at the top level of the composable hierarchy and passed to only those composable functions that require navigation. In this video, you learned to define what navigation is and describe its core concepts. You also learned to explain how Jetpack Navigation Component is used with Jetpack Compose and identify the three major parts of Jetpack navigation. In this video, you will learn how to define the navigation in Jetpack Compose. You will also learn how to use the key navigation components, which are the NavHost and the Nav Controller. You will also define the destinations and the routes to navigate from one basic screen to another. Since the purpose here is to explain how to use the navigation API in your Little Lemon app, I am going to create two basic screens to simulate the home screen and the menu list screen of the Little Lemon app, and then navigate between them using Compose navigation. Let's start. I've already created a new project with empty Compose activity. The name of the project is Basic Navigation. On the screen is the main activity. Before I start implementing the navigation, I need to inform Gradle that I'm going to use the navigation component APIs in my Compose project. Gradle is a build system installed in Android Studio that is responsible for building the app so that it can be run on an emulator or a real-life mobile device. In the Project Explorer under Gradle Scripts, I open the build.gradle module file. I scroll down to the Dependencies section and I add the dependency for the navigation component in a new line at the start. You can add the dependency anywhere in the Dependencies block. I'm going to sync the project by clicking the Sync Now button in the top right-hand corner. Once the sync is complete, I start to create the two basic screens. It is good programming practice to keep the screens in separate Kotlin files. So, I right-click on Windows or Control-click on a Mac on the package name. Under New, I select Kotlin class file. I now type the name of file home screen and select File from the list below. A new tab opens with the name homescreen.kt. In this file, I create a composable function named homescreen, which is the same as the file name. I'm going to keep this composable simple since my objective is to demonstrate the use of navigation components. I add a column, and to keep its contents in the middle of the screen, I define a fill max size modifier and set the vertical arrangement and horizontal alignment as centered. I now add text object with the text home screen to the column and set the font size to 32 SP. To import the SP library, I press the shortcut above. I then add a button with the text Order Takeaway that has a font size of 20 SP and a background color matching the Little Lemon style guide. To add the color, I will set the colors property to buttonDefaults.buttonColors. And in button colors, I will set the background color to the hexadecimal color, which is 0xFFF4CE14A. I'll soon click the On-Click functionality for the button. Like the Little Lemon home screen, I now create a new Kotlin file for the second Little Lemon screen. The file name is the menu list screen.kt, where I define a menu list screen composable. I now add a column, set the contents to the middle, and a text in the same manner I did for the home screen. I don't want a button here. Now, since the screens are created, let's start implementing the navigation. I first need to define the destinations, so I create a new Kotlin file called destinations.kt. In this file, I define an interface called destinations, in which I add a variable root of string type. This interface will be used to extend the destination objects. Note that a root is roughly the equivalent to defining an ID for a destination. I am now creating the destination object for the Little Lemon home screen and name this Home. This object will implement the destinations interface. I override the root and assign it the value Home. The destination object for the menu list screen is created in the same way. I now assign the value menu list to the root. You may remember that the object keyword is used for creating an object without creating the class. Once the destination objects are defined with the roots, I go to the main activity to define Nav Controller and NavHost. The Nav Controller must be created at the top of the composable hierarchy. So I now create a composable named My Navigation and call it inside the set content. My Navigation is now my top-level composable. I also create Nav Controller inside My Navigation by calling the Remember Nav Controller function. I also create Nav Controller inside My Navigation by calling the remember nav controller function, and a reference of it must be passed to the functions that perform navigation. Next, I create NavHost and pass the nav controller as an argument to it. Instead of defining the graph, I use start destination and set it to the home screen route. The Composable function is used to define the routes in NavHost. This function takes the route and the composable screen as its parameter to navigate. Now I call the Composable function and pass the home screen route. For navigation, I call the home screen function. I do the same for menu list. Next, I pass the nav controller to the home screen composable so that I can use it to navigate from the home screen to the menu list screen when I press the button. The home screen composable doesn't have an argument. To fix that, I click on the red bulb icon on the left of the statement and click Add Parameter to Function Home Screen. Finally, I go to the Little Lemon Home Screen Kotlin file. I now call the navigate function of nav controller with the menu list's destination in the onClick listener of the button so that I can navigate to the menu list screen. Now let's run the Little Lemon application. When I click the Order Takeaway button, I navigate away from the Little Lemon home screen to the menu list screen. The navigation works perfectly. Additionally, the back navigation works by pressing the back button because Nav Controller handles it automatically. You have now learned how to define the navigation in Jetpack Compose. You have also learned how to use the key navigation components in your Little Lemon app, which are the NavHost and the Nav Controller, and defined the destinations and the routes to navigate from one basic Little Lemon screen to another. You have made significant progress in learning about navigation and its major parts. And now is the time to implement it in Jetpack Compose in the Little Lemon app. In this video, you will learn how to define the navigation using the Nav Controller, NavHost, and NavGraph in Jetpack Compose. You will also learn how to add the required dependency, create two screens for navigation, add destinations, and implement the main navigation components to make the navigation work. Let's start by recapping the essential concepts before starting implementation. First, each screen in the app will be called the destination. NavGraph is a collection of navigatable destinations. The NavGraph is provided to NavHost for building the navigation graph. NavHost acts as a container for displaying the current destination. It takes the Nav Controller as an input parameter and associates it with the NavGraph. Finally, Nav Controller is responsible for navigating between destinations while managing the backstack. The objective of this video is to create two screens and navigate between them using Compose navigation. The first screen is Dashboard Screen, which contains the text Dashboard Screen and a Next button. On pressing the Next button, the app will navigate to the Details screen. Let's further explore these concepts and put them in practice in Android Studio. First, I have created a basic navigation project containing a single activity. The main activity is not linked to any view. Now to implement the navigation, I need to add its dependency. I open the build Gradle module file and add the dependency. Let's sync the project. Now I create a Kotlin file for the dashboard screen, dashboard screen KT. In this file, I create a composable function named dashboard screen, similar to its file name. In this function, I add a column with a modifier to fill the maximum size and align the content vertically and horizontally centered. This column contains a text dashboard screen with a font size of 48 SP. Now, I add a button with the text Next to be used for navigation. I will be going to implement the on-click functionality later on. Let's preview the Composable with Show Background enabled. I will click on Split on the upper right corner to display the preview. Then I click on Build and Refresh to update. Next, I will create a new Kotlin file for the second screen. The file name is the Details screen. In this screen, I copy and paste the content from the dashboard screen and change the function name from the dashboard screen to the detailed screen. Next, I update the text to the detailed screen and remove the button. Previously, you learned that a nav graph requires routes, so I will create a Kotlin file for the destinations along with their routes. In this destinations file, I will create an interface containing a variable route of string type. This interface will be used to extend the destination objects for routes. Let's create the object for dashboard screen and name it the dashboard which implements the destinations interface. I override the route and assign the value home. The object of the details screen is created the same way. As a reminder, the object keyword is used for creating an anonymous object without creating the class. In the main activity, I create a composable navigation function and name it myNavigation. I call this function in the setContent for the starting point. The complete navigation will be from this function, so I create Nav Controller through the Remember Nav Controller function. It is important to note that Nav Controller must be created on the top of the composable hierarchy, and a reference of it must be passed to the functions that perform navigation. This Nav Controller will be passed to the NavHost as a parameter. Instead of the graph, I use the start destination, which in my case is the dashboard screen route. The Composable function is used to define the routes in NavHost. This function takes the route and the Composable screen to navigate to as its parameter. Now, I call the Composable function and pass the dashboard screen route. For navigation, I call the dashboard screen function. I do the same for details. Let's pass the Nav Controller to the dashboard screen for navigation to details screen. I click on the red bulb icon and add a parameter to the function dashboard screen. I go to dashboard screen to remove the preview because the preview function cannot take parameters. Finally, I call the navigate function of Nav Controller with the details destination in the on-click listener of the button to navigate to the details screen. Let's run the application. Now, the navigation works perfectly. Additionally, the back navigation works by pressing the back button because Nav Controller handles it automatically, without adding extra functionality. In this video, you learned how to define the navigation using the Nav Controller, NavHost, and NavGraph in Jetpack Compose to create navigation in the Little Lemon app. You also learned how to add the required dependency, create 2 screens for navigation, add destinations, and implement the main navigation components to make the navigation work. Good job! You learned how to navigate between different screens using Jetpack Compose. Now, it is time to create bottom navigation. In this video, you will learn to implement bottom navigation. You will also learn to navigate among different screens using the bottom navigation in our Little Lemon app. Generally, bottom navigation is used for the primary destinations, which need to be accessible from anywhere throughout the app. It is best practice that the bottom navigation must contain 3 to 5 destinations. Each item in the bottom navigation is known as bottom navigation item. It is common practice to use a title and the icon for each bottom navigation item along with the route for navigation. Let's now cover how to implement bottom navigation in the Little Lemon app in Android Studio. I have opened the bottom navigation project. The set content contains the call to an empty composable, namely My App. I go to Project Explorer and open the build.gradle module file. I add the implementation androidx.navigation-compose:2.5.3 to the dependencies block. I sync the project. Now I create a Kotlin file for home screen. In this file, I add a composable function with the same name as the file. I add a box with a modifier to fill the maximum size and centered content alignment. Next, I add the text home screen to it. I change the font size to 48.sp. Next, I create another Kotlin file for the settings screen. I copy the content from the home screen and paste it into this file. I replace the composable name to match the file name and the text as well. Now I create a Kotlin file for destinations. I add a destinations interface. Next, I create the variable route, which is a string, the icon of image vector type, and the title for the bottom navigation item. I create the home object while implementing the destinations interface. I assign the value home to the overridden route variable. I assign the icons.filled.home as the icon. And I set the home as the title. Similarly, I create the settings object. I use icons.filled.settings as the icon, and I set settings as the title and route. I create a composable My Bottom Navigation in main activity. I add the nav controller parameter to it. In the Composable, I create a variable destination list with the list of destinations. Then I create a variable selected index by remember savable with mutable state of 0, which selects the 0th item, home in the list. Next, I add bottom navigation. Inside it, I iterate the destination list with for each indexed. I add index and destination parameters along with the arrow. I then add a bottom navigation item and set the label parameter to the text object with the destination's title. I set the icon parameter to the icon object with the destination's icon. I pass destination title as second parameter. I set the selected parameter to index equals selected index.value to display the item as selected when it matches the selected index. I set the selected index value equal to the index in items on click function. I then call the nav controller.navigate with destination list with root. Inside the curly braces of navigate, I call pop-up to home.root to remove everything from stack till home screen. And to prevent adding the same screen more than once, I set launch single top equals to true. Inside the My App Composable, I create a nav controller by the remember nav controller function. I then add a scaffold and pass the My Bottom Navigation function in the bottom bar attribute. I pass the nav controller to My Bottom Navigation Composable. I create box for padding values of the scaffold with NavHost inside it. I pass the nav controller as first parameter and home.root as start destination. I call the Composable function and pass the home.root. Inside the curly braces, I call the home screen Composable. Similarly, I also call the Composable function for settings. Inside the curly braces, I call the settings screen. Let's run the app. Now my bottom navigation is working correctly. In this video, you learned how to implement bottom navigation. You also learned to describe the usage of the pop-up to and launch single top while navigating. Good work. You previously learned about navigation in Jetpack Compose. It is now time to explore lists in greater detail, as this will help you to display lists in your Little Lemon app. In this video, you will learn about lists in Jetpack Compose and how to populate vertical and horizontal lists of items by iterating over them. You will also discover how to arrange the items within a list. Let's first explore lists. Lists are used when you need to display several items, and they can either be vertical or horizontal. In your Little Lemon app, there is a horizontal list of food categories in the middle of the screen. The horizontal lists are defined using a row. A row is simply a layout composable to place its children in a horizontal sequence. There is also a list of dishes that Little Lemon Restaurant offers. For vertical lists, you use a column. A column is simply a layout composable to place its children in a vertical sequence. The horizontal arrangement can be used for the row to define the horizontal position of its children. The vertical arrangement for the column is used in a similar way, to vertically define the position of its children. There are several types of arrangements available in Jetpack Compose. Let's explore a few of these arrangements in greater detail. The space between is an arrangement position where the first child starts and the last child ends, and equally distributes the remaining items in between. The space around arrangement adds space to the first and last child, while keeping others in the center. As its name suggests, the space evenly arrangement adds equal space to all children, including space at the start and end. And finally, start moves the children to the beginning, center centers the children, and ends moves them to the end. Now let's implement the lists and see how these arrangement types work. In this video, you will learn how to code a simple horizontal and vertical list using a row and a column. You will also learn how to use the properties of lists to arrange the elements in them. I have created an empty Compose project. Currently, the setContent function is empty. I now create a category Composable used in the Little Lemon Apps menu. I name this Composable Menu Category. I will define a category parameter of string type. In this Composable, I add a button. Next, I add a color to the button by setting the colors property to buttonDefaults.buttonColors with a background color equal to color.lightgray. I set the shape property to rounded corner shape with a percentage of 40. I add the padding of 5 dp. Inside the button, I add a text and set the object's text property to the category parameter I defined above. I will create a composable with the name of Menu Category Preview and add a preview annotation with the show background set to true. I call the menu category Composable and pass the value category as its parameter to view it. I click on Split and press Build and refresh. I create a list of 3 categories to display at the end of this file. I now create a row in the setContent and set the modifier to fill the maximum width. Inside the row, I add a list dot for each of them to iterate over the list. I will call the menu category Composable, passing it as the value for each item. Let's run the app. The horizontal list of items seems good. Right now, the items are attached to start. I set the horizontal arrangement property of the row so that it is spaced evenly for items to fill the space at the end. Let's replace the row with a column and change the modifier to fill the maximum height. I will remove the horizontal arrangement because it is used for row. Let's rerun the app. Here is a vertical list of the categories. I set the vertical arrangement to center to align the items to the center. In this video, you learned how to create a vertical and horizontal list. You also learned to arrange the items using the arrangement property of row and column. Now you know about lists in Jetpack Compose and how to populate vertical and horizontal lists of items by iterating over them. You also explored how to arrange the items within a list. Great job! You have already learned about row and column in Jetpack Compose and how to apply it when creating your Little Lemon app. In this video, you will learn what a grid is and how to display the grid in your Little Lemon app. You will also learn how to make a column scrollable. Although your Little Lemon app contains a list of dishes on the home screen, you can also define a grid layout. Let's start by defining what a grid is. In Android, a grid is a scrollable layout that displays the items in 2 dimensions. A grid consists of both rows and columns. Each item in a grid is known as a cell. For a column to be scrollable, the vertical scroll property of modifier needs the parameter called rememberScrollState. You can use the rememberScrollState function to allow a changing scroll position or for observing scroll behavior on your Little Lemon app. Now that you know what the building blocks for creating the grid are, let's start implementing the grid. In this video, I will create a grid cell, which will be repeated to display the grid view. Let's open the Little Lemon project. I have opened the main activity. In the set content, the app screen function is called, and it is empty for now. I now create a menu grid Kotlin file for the grid. I start by creating a composable grid cell that will be displayed in the grid. I add a card with elevation of 16 dp. I set the padding modifier to 8 dp. Next, I add a box in it because I want my item to look like a box. Then I set the required size to a width and height of 180 dp. I also add the padding of 8 dp. Inside the box, I add an image. I set the painter to painter resource with r.drawable.greeksalad and the content description to Greek salad. I've already placed the image in the drawable, which I am referencing here. Now, I create a title for the image. So I create a text object with using the text Greek salad. I add the font size of 18.sp. I set the font weight to bold, and I then add the modifier to fill max width. I add the padding of 4 dp, so the text is not attached to the start. I set the background color to white, and I align the text to the start. I also add the price of the item. To do this, I create a text object with text of $12.99. I will set the font size to 18 and font weight to bold, as I previously did for the title. I then add a modifier width and select a white background. I also add the padding of 4 dp to the start and end, and I then add the alignment to the bottom end. Next, I add the menu grid Composable, and to review the item, I call the grid cell in it. Let's run the app. The grid cell seems good. In the menu grid Composable, I add a column with a modifier called vertical scroll and pass the rememberScrollState to make it scrollable, so that it remembers the state to observe the column when it is scrolled. I want to show 10 items in the list, so I use repeat and add the value of 10 to it. Let's run the app to see the column scrolling. There is now a list on the emulator that is scrollable. To make it a grid, I add a row. I set the modifier to fill max width. I then add the horizontal arrangement so that it spaces evenly. I want to display 2 items in each row, so I add repeat and set the value to 2. I cut and paste the grid cell in it. Let's run the app. The grid is now working and is scrollable. Congratulations! You have successfully learned to create a scrollable grid using the row and column. In this video, you learned what a grid is and how to display the grid in your Little Lemon app. You also learned how to make a column scrollable. Well done! You have made great progress in your learning journey on the advanced elements in Jetpack Compose. You previously learned about rows, columns, and how to make them scrollable. Let's explore what you will learn in this video. In this video, you will be introduced to lazy layouts, their purpose, as well as when to use them. You will also learn about the different types of lazy layouts, which includes lazy lists and lazy grids. You previously learned to use row and column to build a vertical and horizontal list in the Little Lemon app. You learned to use a row and column to build a custom scrollable grid. These lists and grids you have learned about are normally used when you have a small number of items. But if you need to have a large number of items, or items of unknown length, they can cause performance issues because all the items are composed at the same time. To fix this problem, Jetpack Compose provides components such as lazy row, lazy column, and lazy grid, which only composes that which is visible in viewport, rather than composing it all at once. It improves the app's responsiveness and performance of the app. Lazy row is like row. It creates a horizontal scrollable list. Lazy column is the same as a column. It creates a vertical scrollable list. Both the lazy list and the lazy column can be used to add the items to the list. This allows you to describe the content for the item or items, and lazy list takes care of everything else, such as scrolling and recomposing items when required. Compose API can provide a single item using an item block or multiple items using item blocks. They can also be used in combination. Let's first explore an example of code for a lazy column. In this code, lazy column is created with a single item that contains a text header. It includes 10 items and also has another single item containing text as a footer. This is a vertically scrollable list, and to make it horizontal, you need to replace the lazy column with lazy row. You can also use items indexed instead of items in cases where the items are required along with the index. You may, for example, want to color the even or odd items separately in your Little Lemon app. Let's explore another piece of the lazy layouts code. This code passes the list of strings to items indexed. Now the index and item can be used as required through the lambda expression. Compose provides two types of grids, which are called lazy vertical grid and lazy horizontal grid. A lazy vertical grid displays the items in a vertical scrollable grid, spanned across multiple columns. The lazy horizontal grid displays the horizontal scrollable grid, spanned across multiple rows. Now let's discover how to add spacing outside and within the items. To add the padding around the content displayed in the lazy lists and grids, the content padding attribute can be used. An example of adding padding to lazy column can be, in this example of adding padding to a lazy column, a padding of 8 dp is added to the start and end of the horizontal property. Padding is also added to the top and bottom of the vertical property. A space between the items of the lazy column can be added by using the vertical arrangement the same way it was added for the column, and in the same way it was added for rows. A space can be added between the items of lazy row using the horizontal arrangement. You have now learned the concepts of lazy lists, what they are used for, and how to use them in your Little Lemon app. Well done. In this video, you will learn how to define the lazy list in Jetpack Compose. You will learn how to define lazy row and lazy column. You will also define the data and populate the list using the data you defined. I will explain what I already have in my lazy list project. I have created a Kotlin file and named it the menulist_screen.kt. The file is present in my package name folder. In this file, there are two composables that were developed in a previous lesson, the menu dish and the menu category composables. The first composable is menu category. I will use this composable for displaying the list of categories. The second composable is menu dish, which I will use to populate the list of dishes displayed in our Little Lemon app. I have already added 3 images for the dishes: Greek salad, bruschetta, and lemon dessert, which you can find in the drawable folder under RES. Let's go to the main activity file. Inside the main activity, the set content is empty. Before I start implementing the lazy list, let me show how the menu category and menu dish composables look like. To do that, I add a column and call both composable functions in it. When I run the app, the output displays the UI of both composables. On the top, the menu category composable shows a button with the grey background. The menu dish composable shows the menu item laid out with the title, description, price, and the image. Now, let's set up the data that the list items will show. I start by creating the data repository, which will be used for the data we will display in our lazy list. I right-click on Windows or Control-click on a Mac, the package name, go to New, and select Package. I name this package Data. It is best practice to place the data sources in the data repository. So, I create two data files in this repository, one for categories and the other for dishes, which are available in the menu of the Little Lemon app. Let's create the Kotlin file for categories. I right-click on Data, go to New, and select Kotlin class file. I name it Categories. I select File and press Enter. In this file, I will create a variable categories and assign a list of strings containing some of the categories used in Little Lemon. Similarly, I will create the file for Little Lemon dishes. Then, I create a data class and name it Dish. Each dish contains a name, price, description, and image. Next, I have to create the variables for dishes and assign a list of dish objects with their values. I had already written the data for 3 dish objects, which I just pasted here. I duplicate these dish objects just for the sake of having more number of objects for only the demonstration purposes. Remember that in a real-world scenario, the data for our Little Lemon app will be coming from the database. Now I open the menu list screen.kt file and close other files on the top to keep my interface clean, and I double-click the menu list screen file on the left. I add a composable menu list screen function for displaying our menu list. I add a column to this function for populating the content vertically. I add lazy row because our categories are horizontal. Lazy row is similar to row, but it is used for horizontal scrolling lists. It loads the items as required to display and improve performance. To add the categories, I iterate over the categories with items and pass each category to the composable menu category. The red line under the categories shows there are too many arguments for the function error. To fix this error, I click on the red bulb on the left of my code and select Add Parameter to Function Menu Category. I scroll down the composable menu category and replace the hard-coded string for text with the category variable to display the category parameter in text. To have a clear difference between both lists, I add a divider after the lazy row with a modifier with a padding of 8 dp. I use a light grey colour for it, and I set the thickness to 1 dp. I add lazy column to display the dishes vertically. To recap, lazy column is similar to the column, but is used for vertical scrolling lists. To add the dishes, I iterate over the dishes with items and pass each dish to the composable menu dish. To fix the error, I click on the red bulb to the left of my code and select Add Parameter to Function Menu Dish. Next, I scroll to the composable menu dish and replace the text Greek salad with the dish.name. Then, I replace the text for description with the dish.description. And I replace the text for the price with dish.price. And finally, I replace the painter resource with the dish.image. Now I go to the main activity and replace content in setContent with the menu list screen composable function. Now I can scroll the list of categories horizontally. I can also scroll the list of dishes in the app's menu vertically. You have learned how to implement the lazy row to display a list of items that can be scrolled horizontally. You have also learned how to implement a lazy column to display a list of items that can be scrolled vertically. You also learned how to create a data class and a list of the objects from this class. In this video, you will learn how to create a simple lazy grid. A lazy grid in Jetpack Compose is a grid of an unknown or large number of elements. You may also now know that in the case of lazy composables, Jetpack Compose only composes or recomposes the items visible on the screen. Like lazy lists, Jetpack Compose provides vertical and horizontal grid composables in the lazy grid. You will explore how to use a lazy vertical grid to demonstrate grid development. Later in this course, you will have an opportunity to use what you have learned about defining lazy grid when creating your Little Lemon app. Let's create a simple lazy vertical grid. I have created an empty compose activity. Recall that you have learned how to do this previously. This is the main activity with an empty set content inside the onCreate function. I now define the lazy vertical grid, which is a built-in composable in Compose. I start typing lazy, select lazy vertical grid from the pop-up and press enter on my keyboard. Now, I need to define the columns parameter for the vertical grid, which controls how grid cells are arranged into columns. I have two choices. I can choose to specify a fixed number of columns, or I can choose to inform the grid of the minimum size of the cell I want and let the grid decide and fit as many columns as possible. Let's first use the first choice and develop the grid. I type gridcells.fixed and pass in the number 3 to indicate that I want my grid to contain 3 columns. I can remove the content parameter and use the trailing lambda. You may remember that in Kotlin, if the function's last parameter is a function, then a lambda expression can be passed through curly braces at the end of the function call. I want my grid to have 500 items or cells. So, in the body of the grid, I type items and give a count of 500 to them. In the items content, I call a function the grid cell, which will define the cell of the grid. I define the number parameter in the items block. Next, I call a function named myGridCell, which defines the cell of my grid. I pass the number parameter to it. I use this number parameter to uniquely identify each cell. Android Studio marks the call to myGridCell in red, complaining that this function does not exist. I now start defining the myGridCell composable. I name this function myGridCell and pass a parameter number of int type. To display the cells prominently, I add a card and set in the modifier with a padding of 8 dp. I also set the elevation for the card to 20 dp. Next, I will add a box, because I set each item to be centered in a box-shaped card. I set the modifier with an aspect ratio of 1f to maintain the height and width equally. I set the content alignment value to alignment.center to ensure that the content is in the center. Now I add a text object inside the card. I also set the text property of the text object to item and concatenate the number after space. I set the font size to 20.sp. This is all I need at minimum to define a grid. Let's run the app. The grid contains 3 columns and scrolls efficiently. Now let's rotate the device to see how it adjusts to the items. There are still 3 columns and the items are increased according to the width. Now, instead of using a grid of a fixed number of columns, I want the grid to set the number of columns for me, given that I define the minimum size of my cell. I hide the emulator and change the gridcells.fixed to gridcells.adaptive and provide the minimum size of the cell to 150 dp. Now I rerun the app. The grid contains 4 columns when the orientation of the device is horizontal, and when rotating the device to a vertical orientation, it shows 2 columns. You now have learned how to define lazy vertical grid. You have also learned how to use the fixed and adaptive grid cells. You've reached the end of this module, where you learned about advanced UI with Jetpack Compose. In this module, you got started on building interfaces that consist of multiple screen and extend beyond visible screen area using Jetpack. First, you covered Jetpack navigation. Then, you explored lists and grids. Finally, you studied lazy layouts. It's now time to recap the key points you learned and skills that you gained in each of these areas. You began the module with an introduction to Jetpack navigation. Following the completion of this first lesson, You now can set up a navigation graph in Navigation Editor, define and link destinations with Navigation Editor, describe the navigation graphs using Navigation Editor, define the actual navigation using NavHost and Nav Controller API, explain bottom tabs with bottom nav bar, and define navigation across tabs. So, you can use your knowledge on these topics throughout this course. Following the introduction to Jetpack navigation, you started learning about lists and grids. Now that you've covered lists and grids, you can discuss the use of lists, show how a list can be built by iteratively composing a single definition of a list item composable, build lists vertically or horizontally using row and column layout, implement a grid, make lists and grids scrollable when the item overflows the screen bounds, define vertical and horizontal scrolls, exemplify the use of the nested scroll modifier, and maintain the scroll state with scroll state and remember scroll state. In the next lesson, you learned about lazy layouts. Now you can explain how large data and too many list items can cause inefficiencies in composition. Define lazy column and lazy row composables and exemplify it with a lazy list. Explain the use of content padding and content spacing modifiers. You can also remember lazy list state across configuration changes and build a horizontal lazy grid with stylized appearance. You're now familiar with the basics of advanced UI in Jetpack Compose. Excellent work. You've made great progress. You have made great progress learning about advanced UI to continue building the Little Lemon UI for Mario and Adrian. You previously learned about navigation, lists, grids, and lazy layouts in Compose. Now, you will learn how to style your UI with themes. In this video, you will learn to explain what themes are and why they are important. You will also learn to identify what design aspects they cover. A typical application consists of multiple screens, each having its own set of components, like texts, lists, grids, buttons, and so on. You need a mechanism to unify and maintain the application look and feel across all these screens. Themes allow you to separate application design details from the UI structure and behavior. You can have two screens containing the same composables: header text, description text, image, and two buttons. Yet they may look different. The appearance is controlled by the application theme. A theme is composed of a collection of attributes. A single attribute can represent font size, shape, typography, color, spacing, and more. These attributes are used by composables, styles, layouts, and so on. For example, a theme may specify a header text size of 10sp, grey text color for regular text, and button height of 20 dp with a blue button background. Jetpack Compose includes a material design implementation that you can use to create a base for the application UI. It contains components including cards, buttons, and switches. These components are taking advantage of the Android theme mechanism and can be easily themed to better reflect a product's brand and create a unique app look and feel. Declaring all the attributes in a theme allows you to reuse them across the entire application, leading to consistent component design. In other words, themes serve as a single source of truth regarding the application UI. Android Material Design provides a dedicated built-in themes, including day-night themes that automatically toggle between the light and dark modes of the application. The dark theme is applied to Android's UI as well as applications running on the device. Dark theme can reduce power usage and makes it easier for anyone to use a device in low light conditions. Color schemes are designed to ensure accessible text and distinguish UI elements and surfaces from one another. Themes can also be used to style UI elements outside of the Android application, such as window background and system status bar colors. Themes define the look and feel for the entire application, activity, or view hierarchy. A theme is a collection of styles, The style specifies a collection of attributes for a particular type of component. Themes contain styles for buttons, lists, grids, images, and many other composables. Themes contain styles for buttons, lists, grids, images, and many other composables. Instead of modifying the design of each composable individually, you should adjust the value of the attributes responsible for the composable by modifying its style. This change will be applied to every screen in the application. For example, a new background color for a button will be applied to all buttons in every application screen. You may wonder what would happen if the same attribute is defined in the theme, in the style, and in the composable. Attributes have priority hierarchy. The closer to the composable, the higher the priority of an attribute. If a given attribute is provided for the composable, then it overrides the same attribute defined in style. If an attribute is provided for the style, then it overrides the attribute defined in the theme. This hierarchy allows you to change the primary color for all components in the application, and at the same time override it for a single type of component, or even a single component instance. In this video, you learned to explain what themes are and why they are important. You also learned to identify what design aspects they cover. Now you know what themes and styles are. You may use them in the Little Lemon app that you are creating for Mario and Adrian. Well done! You have learned about various lazy layouts in Jetpack Compose. In this video, you will learn how to style the application user interface or UI, so that the UI colors will conform to the Little Lemon brand colors. You should then be able to identify how colors are represented in the application and set colors for the application screen. In Android, colors are represented as hexadecimal ARGB values. The ARGB acronym stands for alpha, red, green, and blue. Let's take an example to understand what ARGB means in practice. The beginning 0x represents a Kotlin prefix for defining hexadecimal numbers, so this is not really part of the ARGB. The first two actual ARGB characters represent the value of the alpha channel, which determines how opaque or transparent a given color is. To visualize opacity, just think about glass. Some bottles are fully transparent, and you can see right through them, while others are less transparent and have a color. A 00 value means the color is fully transparent, while FF means it is fully opaque. The next 6 characters represent the colors red, green, and blue. For any given color, FF means full color, while 00 means no color. It is like mixing these 3 colors in real life to create a new color. For example, mixing red and green will make yellow. Setting all 3 colors to the full value using FF will produce white, while setting all colors to minimal values of 00 will produce black. Now that you know about colors, let's start styling the Little Lemon application UI to align it with the colors of the Little Lemon brand. I will apply a unique look and feel by using the Little Lemon brand colors. I will apply colors to style the application UI. I create a color.kt file and define the Little Lemon color object. Inside the object, I paste the color definitions representing the Little Lemon brand colors. These colors are represented as ARGB values and wrapped in a dedicated Jetpack Compose color class. Notice that Android Studio displays actual color previews close to the line number. I open the lower panel KT file and display the preview. The initial state of this composable displays without the Little Lemon brand colors applied. I hide the preview panel. Next, I add the color attribute to the weekly special text composable. I set the value to charcoal. This color is retrieved from the Little Lemon color set defined earlier. Next, I modify the dish title by using the same color. Now I set the style of dish description by using the Little Lemon green color. I also set the price color to green. To make each dish distinguishable from another on the list, I will change the divider color to yellow. I show the preview panel and refresh the Composable to check the implemented changes. The Composable displays as expected. I open the upper panel KT file and display the preview. The initial state of this Composable displays without the Little Lemon brand colors applied. I hide the preview. I make the content background darker by providing the green color value as the content background for the column Composable. It is important to note that the background color must be applied before the padding. Otherwise, the padding will not display on the screen. I also set the restaurant name title color to yellow. Next, I update location and description colors to cloud color in each text Composable. I need to provide a more distinctive look for the Order Takeaway button, so the user will recognize it as a call to action. Now, I set the button background color to yellow. I show the preview panel and refresh the Composable to check the implemented changes. Finally, I open the main activity to check the home screen composed of both Composables. The application screen looks much better now. In a later video, I will apply the text style to improve the screen look and feel. In this video, you explored how colors are represented in the application using ARGB, and you learned to change the colors of various Composables to set colors for the application screen. You have already learned about color format and ways of changing Composable colors. In this video, you will learn how to apply text formatting in the application UI so that you can emphasize the most important text elements in the app. Mobile applications often show a lot of text information on the screen. Even if the application mostly shows media content like images or video, text is an essential part of any mobile application. After applying the concepts described in this video, you should be able to identify how to style text and to apply text modifiers. Compose offers various types of text components used to display text and handle user input. The most used one is the text Composable. To facilitate multiple languages, text is usually retrieved from resources. This approach also allows you to easily update given text across an entire application. The text Composable has multiple optional parameters to style its content along with a required text parameter. You can modify text Composables including color, size, font style, font weight, family, letter spacing, and others. It is also possible to set text vertical alignment to left, right, or center, and horizontal alignment to top, middle, or bottom. And there are other parameters available, such as overflow, wrap, and line height. Each of these style options defines a specific text or paragraph style that can be applied across multiple composable elements. You can use as many options as you like. They all work together to produce the desired result. Unlike the width and height of other Composables, which are set in density independent pixel, or DP, the text size is set in scalable pixel, also known as SP. The main difference between DP and SP is that SP takes the text size setting of the user device into consideration when deciding what text size should be displayed. The user may modify this setting in the Android system preferences, and the text size is scaled accordingly in the application. Now that you know about text styles, let's start styling the text to define a unique look and feel for the application user interface. I will apply the text styles to mark the most important pieces of information on the Little Lemon app home screen. I open the lower panel KT file and open the preview. The initial state of the Composable without text style is displayed in the preview. I hide the preview. Now I make the weekly special title more eye-catching by increasing the font size and making the font bold. I set the font size and font weight parameters. I set the font size to 26 SP and the font weight to bold. For now, I hard code these values for every individual Composable. However, you are going to learn about an alternative approach later in this course. Next, I modify the text that displays the dish name. I set the font size to 18 SP and the font weight to bold. To make the price more visible, I set its weight to bold. I show the preview panel and refresh the Composable to check the implemented changes. The Composable displays as expected. I open the upper panel KT file and display the preview. The initial state of the Composable without text style is displayed in the preview. I hide the preview. I make the title more distinctive by applying the font size of 40 SP and the font weight to bold. The restaurant location is also an important piece of information, so I style it to bold as well. For the restaurant description, I set font size to 18 SP. Now I set the text formatting for the most important button in this component, the Order Takeaway button. I use font size of 18 SP and bold font weight. I show the preview panel and refresh the Composable to check the implemented changes. The Composable displays as expected. Finally, I open the Main activity to check the home screen composed of both Composables. The home screen consisting of both Composables displays as expected. The application screen is fully styled now. Congratulations, you have successfully learned to style the text. In this video, you learned how to apply text formatting in the application UI to style the text so that you can control the look of the app to emphasize important text elements. You previously learned about the function of themes, and you also learned how to style the texts and apply several colors to the UI elements in your Little Lemon app. In this video, you'll explore the material design theme in greater detail, as well as discover how to apply a consistent design throughout your whole app. Applications in Android consist of several UI elements, including buttons and texts, which are used several times on the same or different screens. The theme helps to create a custom design according to the product's brand. It also helps to customize and unify the design of UI elements, for example, images, cards, texts, and buttons. Let's explore an example of the material theme Composable defined in Jetpack Compose. The material design provides two functions for defining colors, which are dark colors and light colors. The dark colors function is used to define the colors when the Android system is set to dark mode, whereas the light colors function is used to define the colors that will be applied to your Little Lemon app when the user is using light mode. The material theme includes primary and secondary colors, and variants in both light and dark modes. It also includes additional colors for the UI, such as errors, surfaces, typography, backgrounds, and iconography. As its name suggests, the primary color is the frequently used color in the application. It is commonly used for the app bar, tabs, and buttons. The secondary color is used to distinguish the UI element from the screen to make it more prominent. Sliders, switches, and the floating action button is mainly used for the secondary color. Surface colors are used for the surfaces of UI elements, such as cards, sheets, and menus. The background color appears in the background of the screen. The material also supports adding different text styles, including headline, body, and subtitle styles, which you can use to apply throughout your entire Little Lemon app using typography. The shapes parameter is used for defining the shapes. For example, specify corner radius of the button background. Now that you know more about the material theme, let's discover how to apply it. In this video, I will add several UI elements and use the material theme to customize their appearance. I have opened the main activity file of the Little Lemon project. The set content contains the app screen function, which is currently empty. The file also contains two previews for the app screen, one with the light mode and another with the night mode, which is also called dark mode. I add Little Lemon theme in the app screen composable. I then add the column inside the curly braces for the UI elements to appear vertically. I also set the vertical arrangement and horizontal alignment to the center. I now add a text object with the text Little Lemon. Next, I add another text object with the text Chicago. I add a button, and inside the button, I add a text Button 1. I now add another button, and inside the button, I add a text Button 2. I add an outlined button with the text of Outlined Button. I add a slider with value 5F. I then click the split on the top right to preview the composable. I now go to Project Explorer and open the theme.kt file. The dark color palette and light color palette are defined using the dark colors function and light colors function. I will change the primary color for both modes to colors from the Little Lemon Colors object, which was defined in a previous lesson. I change the primary color for dark colors to Little Lemon Color.green. I then change the primary color in light mode to Little Lemon Color.yellow. I build refresh the preview in the main activity to preview the changes. The colors are applied to all the items containing the primary color. I am now going to change the text style using typography. I go to the type.kt file and change the font weight to bold. You may remember that you can define all the styles for the text in this file. These will be automatically applied to the texts in the whole app. I again build refresh the preview in the main activity to display the changes. All the changes are successfully applied. In this video, you learned how to apply the material theme to the UI elements in Little Lemon app. In this video, you explored the material design theme in greater detail and discovered how to apply a consistent design throughout your whole app. Great job! Your clients Adrian and Mario are very pleased with all the features you have included in your Little Lemon app, but has requested some animations in the UI. In this video, you will learn to explain what animations are and why they are important for user experience or UX. You will also explore different animation types as well as various ways of controlling the animations, including transition animations and duration. UX animation is an important part of modern UI design. Animations improve the overall application interactivity, making products more intuitive, and also helps to attract user attention. By bringing the user interface to life, you can improve communication with your end user. And adding motion to UI elements makes the UI not only more visually appealing, but also attracts the user's attention to a specific area or a specific UI component. You can change the visibility of the composable without applying animation. This means that the given composable will instantly appear or disappear from the screen. Let's explore an example of how you could write the code to do this. In this example, the button click will make Composable invisible, and another click will make it visible again. The button click will instantly change the text visibility. After the first click, the Composable will be invisible, and the following click will make it visible again. You can add more animations than the instant appearance and instant disappearance of visible and invisible composables. Jetpack Compose provides a rich set of APIs to enable various animations. One of the most common ones is the Animated Visibility API. This API animates the appearance and disappearance of its content. To add this animation to your Little Lemon UI, just replace the if condition with the Animated Visibility composable, and the text will slide up to disappear and slide down to appear. The Animated Visibility composable smooths out text transition from one state to another, from the component being visible to invisible, and vice versa. This is achieved by generating intermediate animation frames. Each frame has a different text position and size on the screen. A large number of generated intermediate frames creates the illusion of text moving on the screen. By default, the content appears by fading in and expanding, and it disappears by fading out and shrinking. The animation effect can be changed to fade, slide, or shrink. If you want text to fade in and fade out instead, you then need to specify animated visibility enter and exit parameters. This time, each intermediate frame has a different level of opacity. From 0, which means that it is completely opaque, to 1, meaning fully visible. The button click will gradually change the text visibility. The animation will start. The button opacity will be decreased over time, and the button will gradually disappear. A click will reverse this process, making the button gradually visible. The crucial element of each animation refers to the duration of a specific element. You can control how long each given transition will last by providing an animation spec parameter to the fade in and fade out transitions. To make the animation longer, you pass a value of 2000. The animation duration is provided in milliseconds, so 2000 milliseconds mean that each animation will last for 2 seconds. Jetpack Compose provides high-level animation APIs for several common animation patterns used across Android applications. These APIs support best practices of material design motion. You will learn about some of them later in this course. The API can further be extended, so it is possible to create your own custom animation effects beyond the default set of built-in enter and exit animations in your Little Lemon app. In this video, you learned what animations are and why they are important for UX. You also learned about different animation types and explored various ways of controlling the animations, including transition, animations, and duration. You can now use them in the Little Lemon app that you are creating for Adrian. Well done! In this video, you will learn how to animate a value in Jetpack Compose. You will explore how to use a basic animate as state API and animate a value in your Little Lemon app by simply providing the start and the end value. With this API, you can animate several value types. For instance, int, float, color, and DP. You will also discover how to animate the alpha value of the Little Lemon logo. Let's start. I have created a new project using an empty Compose activity. I have also removed the auto-generated greetings composable, and the set content in the main activity is empty. Since I want to use the Little Lemon logo and the lemon icon for animation, I have already created 2 images and added those to the drawable resources. I go to the RES folder where you can see the 2 images. I open these files and find the Little Lemon text drawable image of the logo text and the Little Lemon IMG drawable image of the logo. I will now develop a basic animation where the lemon image fades in inside the logo text boundary. I will make a single click on the screen as a trigger for the start of the animation. I now close both the images and click the main activity file. Inside the set content, I call the composable function animate logo, which I am going to define next. I then provide the function declaration. Inside the function, I want to add the 2 Little Lemon images that I want to display in the middle of the screen. Since these images will appear on top of each other, I define a box. I want this box to fill the entire screen, so I use the modifier and call the fill max size function. Inside the box, I add an image. I'm using a painter resource to get the logo text image from the drawable. I add a content description by typing the Little Lemon logo text. To keep this image in the middle of the screen, I call the modifier.align function and pass in alignment.center as the argument. Similarly, I add the second Little Lemon IMG image. I get the Little Lemon IMG drawable through the painter resource and set the description text to Little Lemon image. Here again, I use the modifier.align function. To test the animate logo composable, I define a preview function. In the preview annotation, I set the show background property to true. Then, within the body, I simply call the animate logo function. I open the preview by clicking the split button in the top right-hand corner. I press build and refresh to load the preview. The preview looks good as both images appear in the middle of the screen. The screen is now set, so let's start writing for the actual animation. I want the Little Lemon image to be hidden at the start so that it can later on be faded in using an animation. In the Little Lemon UI, I will use a screen click trigger to fade the image in. To do this, I want to set the alpha property of the image through the modifier. However, since the alpha will keep changing during the animation, I use Remember API to make sure that the image retains its state during recomposition. So, I go to the start of the animate logo composable function definition and define a var with the name alpha img using byRemember, and then pass the 0 as initial value to the mutable state of the function. Since alpha value is float, I now define a value animate alpha img by animate float as state function. To provide arguments for this, I set the target value parameter to the alpha img variable I declared. Next, I pass the animate alpha img value to the modifier.alpha in the second little lemon image. To trigger the animation, I go to the modifier in the box and define a clickable modifier. As a lambda definition, I simply add a statement to increment the alpha img variable by 1. The animation is almost ready. Let's run the app. The little lemon image is not there yet, but when I click on the screen, it appears almost instantly. This is because the animate float as state function quickly animates the alpha img value from 0 to full opacity. To lengthen the duration of the animation, I define the animation spec parameter for animate float as state function. Simple animation specification can be defined through tween definition, inside which I set the duration millis to 4000 milliseconds, which is 4 seconds. The tween definition animates from the start value to the end value over a specified duration. I now run the app again. The result is that the little lemon image appears slowly over 4 seconds. You have now learned more about how to animate a value in Jetpack Compose, and you explored how to use a basic animate as state API and also animated a value in your little lemon app by simply providing the start and the end value. You should now be able to animate several value types in your little lemon app, and you also discovered how to animate the alpha value of the little lemon logo. You've reached the end of this module, where you learned about UI styling using themes and animations. In this module, you had an opportunity to practice applying themes, custom styles, and animations to develop attractive user interfaces. You learned to define, apply, and customize themes. You also learned how to animate UI elements by applying transitions. It's now time to recap the key points you learned and skills that you gained in each of these areas. You began the module with an introduction to themes. Following the completion of this first lesson, you now can describe what a theme is and why themes are important. Identify design aspects they cover, such as color, shape, typography. Explain the default definition of theme when defining compose activity, and explain the definitions in color.kt, shape.kt, and type.kt. You also learned how to define and apply colors, style text, define terms such as typography, font, and font family, and discuss text style and font-related classes. Then you moved to material design theme. In this topic, you learned to define material design and material theming. Describe custom colors in the material theme, explain font types and shapes in the material theme, and define a custom card in a list with a custom set of colors, fonts, and shapes. So, you can use your knowledge on these areas throughout this course. In the next lesson, you had an introduction to Compose Animation API. After successfully covering this lesson, you now can animate content with the animated visibility Composable, define what transitions are, explain the enter and exit transitions, and you also learned to animate values using animate as state functions with simple examples, animate the size and background color of a composable, and describe motion layout and keyframes. You're now familiar with the basics of UI styling using themes and animations. Excellent work. You've made great progress. You've reached the end of this Create the User Interface in Android Studio course. Well done. You've come a long way, learned new skills, added more tools to your development toolbox, and expanded your understanding of Android development. Take a moment to congratulate yourself and consider all you have learned during this course. This is the end of course graded assessment section of the course, and it contains a final development project where you will get a chance to apply what you've learned. The final project is to create an app user interface, or UI. Your work here includes UI creation in Android, using Jetpack Compose and styling the UI. But before you embark on the final project and assessment, let's reflect on the key takeaways from the course. You began this course with an examination of basic UI creation in Android and an exploration of real-world mobile UI characteristics, focusing on common constraint and design issues. A major new learning area for you in this week included the area of activities. You learned what activities are and examined their operation within the Android development environment. An activity is an app component containing the user interface, and it represents the app screen. You started to write code to implement an activity, and in the Android Software Development Kit, or SDK, every activity is an instance of the activity class. The activity class is responsible for creating a screen or a window which contains the user interface. Jetpack Compose is the latest Android UI toolkit, and it can simplify common UI development tasks. You also learned how to create a very simple app for the Little Lemon restaurant, where you defined an activity in Android Studio using Kotlin. Following the introduction to activities, you started learning about views, both vital components when creating a UI in Android. Now that you've covered activity and views, you can describe how mobile UI is built, identify unique challenges for Android UI, and set up Android Studio so you can use it throughout this course. A view is a single Android UI element, sometimes also called a widget, which is drawn and shown on the screen, and with which a user can interact. Now that you've worked with activity and views, you should be able to describe an activity, define an activity with a single view in a layout, identify common views, and discuss the use of sizing units. You should also know identify common layouts such as linear, relative, grid, and frame, and discuss how XML can represent hierarchies. Jetpack Compose is a UI toolkit that can help you create an Android UI. It can aid your Android development work on areas including activities, views, and layouts. Jetpack is a collection of libraries that focus on helping developers to reduce development time, write less code, and to follow best practices. The Compose part of the Jetpack suite is a library for developing UI. You explored using Jetpack Compose to create the Little Lemon app by building a UI. That included defining composable functions while recognizing their characteristics and developing a simple UI in Compose using Android Studio. We started by developing the Little Lemon home screen step by step. For instance, you defined a composable function for the main panel using a variable called name. Inside the main panel function, the name argument is passed to another function. Text, which is a built-in composable function in Compose library, responsible for creating the text UI element that appears on the screen. Following your work in week 1, you should now be familiar with the basics of UI creation in Android and be able to create a basic UI. There is, of course, more to consider when working with more complex Android UI projects. In Jetpack Compose, you went on to cover how to operate with modifiers, interactivity, state, and learned about laying out composables. A modifier allows you to modify some aspect of a composable that is either related to its appearance or behavior. One of the major uses of modifiers is to configure composables. When using modifiers, you can create an interaction, such as when the user taps on a UI element, or performs interactions like swiping, scrolling, or dragging. State is data or some part of a program's information that changed over time. It may also refer to a current snapshot or condition of a program. So, it is important that the state is remembered by the app to ensure proper execution of the program. For this to happen, you use the mechanism provided by the Remember and State APIs, or Application Programming Interface, in the Compose library. For example, individual UI elements such as buttons, checkboxes, text fields, and sliders have a state. In Compose, the recreation of the app and its view-related elements based on their state may happen frequently and is called recomposition. Recomposition happens whenever state changes. Developing an Android UI with Compose allows you to use its rich toolkit of capabilities to develop exceptional UI designs. To help you achieve that exceptional design goal, you learned what material design and material components are, and you discovered what a scaffold is and how a scaffold provides common layout structures. Material design is a comprehensive design system to create user interfaces. In material design, the individual UI elements are called material components, which carry a standard and adaptable look and feel. This applies to various UI structures and components, including app bars, snack bars, the navigation drawer, and floating action buttons. UI patterns are common UI design structures, which you find in many apps. For instance, an app top app bar containing the name of the app and some buttons is a UI pattern, and it is often used as a composite component consisting of several UI elements. Compose provides a convenient way to combine these UI patterns and material components using a special composable called Scaffold. Scaffolds are customizable layouts that provide support to add various UI structures and components. By the end of week 2, you should have enhanced your skills with Android UI creation and be able to efficiently build a UI using Jetpack Compose. You should then have been able to use layouts in Compose, such as row, column, and box layouts, and create a UI design complete with text, image, and buttons. Following your hard work in weeks 1 and 2, it was then time to add the extra layer of development by exploring advanced UI aspects. This advanced UI work included exploring Jetpack navigation, working with lists and grids, and operating with lazy layouts. You started building interfaces that with multiple screen and extending beyond visible screen area using Jetpack. A typical app has more than a single screen. To help build the navigation from one screen to another, Android Jetpack provides a navigation component. This includes simple actions, such as clicking a button or clicking item on the list, triggering a move to the navigation destination. You also used the Nav Controller to navigate between destinations while keeping track and manipulating the backstack. You used lists when you need to display several items, either vertically or horizontally. You learned how to code a simple horizontal and vertical list using a row and a column, and to use the properties of lists to arrange the elements in them. For instance, to display a list of dishes that Little Lemon Restaurant offers, an alternative to that list of dishes would be to define a grid layout. In Android, a grid is a scrollable layout that displays the items in 2 dimensions, both rows and columns. The lists and grids design approach works well for a small number of items. For a large number of items, you may find it better to use Jetpack Compose components, such as lazy row, lazy column, and lazy grid, because they only compose that which is visible in viewport, rather than composing the entire amount of items all at once. Compose provides 2 types of grids, which are called lazy vertical grid and lazy horizontal grid. A lazy vertical grid displays the items in a vertical scrollable grid, spanned across multiple columns. The lazy horizontal grid displays the horizontal scrollable grid spanned across multiple rows. In week 4, it was time to get familiar with the basics of UI styling using themes and animations. You learned to define, apply, and customize themes. You also learned how to animate UI elements by applying transitions, where you have 2 screens containing the same composables, such as header text, description text, image, and 2 buttons. Each screen may look different. Their appearance is controlled by the application theme. A theme is composed of a collection of attributes, where a single attribute can represent font size, shape, typography, color, spacing, and more. These attributes are used by composables, styles, layouts, and so on. Declaring all the attributes in a theme allows you to reuse them across the entire application, leading to consistent component design. User experience, or UX, animation is an important part of modern UI design. Animations improve the overall application interactivity, making the use of an app more intuitive and also helping to attract and retain user attention. Animation effects include items such as fade in and fade out. The API can further be extended to create your own custom animation effects beyond the default built-in set. At the end of week 4, you should appreciate how the material design theme can apply a consistent design throughout your whole app. You should also have learned what animations are and why they are important for UX, and have explored various ways of controlling the animations, including transition animations and duration. You've reached the end of this course recap, It's now time for you to proceed to the last part of your course and try out what you've learned in the graded assessment. Good luck with that final practical app project for the Little Lemon restaurant. Congratulations on completing this course on creating the user interface in Android Studio. You've worked hard to get here, learned a great deal, and developed a lot of new skills during the course. You were able to demonstrate some of this learning and your practical UI development skill set in Android. Following the development of the Little Lemon Order Takeaway user interface, you learned the concepts required to build a modern UI. In addition to developing these skills, following your completion of this course on creating the user interface in Android Studio, you should now be able to master the basics of creating the UI in Android, discuss the role of activities, views, and layouts, build a UI with Jetpack Compose, set up Jetpack navigation, use lists, grids, and lazy layouts, and style a UI using themes and animations. So what are the next steps? Well, by completing this course, you have gained a valuable understanding of important concepts and practical skills. You probably realize that there's still more for you to learn. If you found this course helpful and want to discover more, then why not register for the other course on the Android Developer Professional Certificate? Throughout each of the courses in the program, you'll continue to expand your skill set. And in the final assessment, you'll bring together all the skills you've learned to manage your own project. Whether you're just starting out as a technical professional or a student, this project will enable you to prove your knowledge and ability. Once you've completed all the courses in this front-end developer program, you'll receive a Meta certificate. Certificates provide globally recognized and industry-endorsed evidence of mastering technical skills. Well done on taking steps towards a future career. Your project experience so far shows employers that you are self-driven and innovative. It also speaks volumes about you as an individual and your drive to continue your educational progress. Congratulations once again on reaching the end of this course. It's been a voyage of discovery. Best of luck, and do continue to pursue your own learning objectives to their final goal.